Hi everyone, welcome to Vedantu NEET English. I'm Diksha, your chemistry master teacher. So everybody, let me know if I am visible and audible to all of you. Everybody in the comment section. Very good afternoon, students. Very good afternoon and good morning. We say good afternoon it is, right? But still, who have just they're like, okay, ma'am, it's our good morning. Then good morning to you, right? Okay. Have class today? Do we have? Yes, definitely you have class today. That's why your ma'am is here. Right. Okay, so everybody, if I am visible, clearly audible also, then let me know. Let me see your chat box. Okay, so today, as on your special demand, because most of you demanded that, ma'am, we need different lecture on organic chemistry. So today we are going to take up some very important concepts of organic chemistry. Now tell me in the comment section what you exactly feel is organic chemistry, because see, I want to know your approach for organic chemistry, right? I want want everybody to write it in the comment section. How do you prepare for organic chemistry, right? Let us see if your approach is correct or if your approach is incorrect. Okay, let us see that. Okay, let me see Karti, Amita, Meghna, Malish, Himashwani, Sanki, Devi. Chalo, I'm waiting for your comments. I think you guys are typing right now. Is it? Headache? Arre. Headache, ma'am. Organic chemistry is a headache. Ma'am, by heart, very good. Tricks, ma'am, okay. Ma'am, I have, okay. Abhigana, okay, Abhigana. By practicing questions, converting reaction, confusing. Very good. Okay, so perfect. I want to see some more comments in the chat box. Guys, a simple thing, right? Starting when we are doing organic chemistry, one thing you need to know that your basic concepts should be very clear. Not even basic concepts, your simple concepts of general organic chemistry should be clear. Okay, right? Because directly from concepts, they ask you around 3 to 4 questions in the exam, sometimes directly, sometimes indirectly. So that means around 16 marks you can get out of this, 16 to 20, not from organic chemistry. I'm saying just from GOC. Okay, so today we are going to focus on the concepts of organic chemistry, right? That we usually skip. Then we say that, ma'am, organic chemistry is very difficult, right? So we are going to focus on these concepts, right? After that, I'm going to start. In the end, I'll ask you what is the next lecture that you want, right, for this Friday itself, right? According to your choice, I will select the topic of organic chemistry. You have a choice of organic chemistry and inorganic chemistry, right? But today lecture is going to be very important because I am not going to do this lecture again before NEET 2025, right? Okay, so this lecture is entirely for those students. Maybe you are very good in organic chemistry, this lecture is for you. You are very poor in organic chemistry, this lecture is for you, because this is going to form the base. Directly you will extract question out of this, and moreover, even if you talk about the other reaction mechanisms, you won't be able to understand without the help of this particular concepts. Okay, yes, okay, okay. Now, ma'am, organic chemistry, please suggest some book. Beta, book is MS Chauhan, right? If you want to like do practice questions of organic chemistry, always it's MS Chauhan. But do level 1, level 2, right? These kind of questions. Don't jump into a very high level of questions. Okay? Yes. Okay, so let us start with the concepts, right? Firstly, when we talk about organic chemistry and what are the things that are going to be very useful to you. So basically, they ask you stability, some questions directly, stability of intermediates, some very important concepts. Then there is acidity and basicity. Then they ask questions from rearrangement, This is a, right now they are focusing on rearrangement of carbocation, a ring expansion, ring contraction, right? These concepts are usually, we think organic chemistry is just about reactions. We forget these concepts, right? That is why this is conceptual lecture of organic chemistry, not a reaction based. Okay, let me be very clear to you. This lecture, we are not going to do any reaction. If you think that organic chemistry is just about organic reactions, no, you are wrong, right? It is about concepts, and today we are going to focus on only the concepts of organic chemistry, right? Okay, you will see for yourself that how from concepts only you will be able to solve so many questions, right? So it is rearrangement of carbocation, and then the last topic that we will do today is ring expansion, and contraction. And all of them we will do with the help of some questions, right? Some previous year questions, some questions that can be asked regarding the previous year questions, or some little bit higher level as compared to your previous year questions, right? Then with our ring expansion, ring contraction, we are going to do, how we are going to do this? Firstly, we will learn the concept here. Okay? Firstly, we will learn the concept here. Now, to understand this concept, to understand stability of intermediates or acidity and basicity, you should be good in few concepts here. That is inductive, mesomeric or resonance, aromaticity, back bonding, right? Okay. These are some concepts, and last one is hyperconjugation. Hyperconjugation, right? These are few concepts that you should be very good in, right? See, if you are good in these concepts, you will be good in stability of intermediates, acidity and basicity, right? If you are good in instability of intermediates, you will be good in rearrangement of carbocation, ring expansion and ring contraction. All these concepts are interrelated, and especially these concepts are used in reactions also. These concepts are used in reactions also. When they ask you what product is formed, that is based on rearrangement of carbocation, ring expansion, ring contraction, and these concepts. That is how just learning the concept, learning the reaction, you won't be able to solve organic chemistry difficult question. Not even difficult, the kind of question that are asked in NEET exam, right? So you should be very good in all these concepts. If you're ready for this lecture, then I'll start. Right now I have given you an overview of what we are going to do today. Okay, yes, okay everybody. If you guys are fully ready for this, then let me know, right? All these concepts, nobody is going to ask me throughout the lecture, ma'am, please do naming reactions, ma'am, distinguish test. This lecture is not, I'm again saying, not for organic reactions, not for distinguished tests. Clearly, it is for organic chemistry, these concepts. And I promise you, after this class of 2 hours, right, I promise you, you will be pro, right? You will be pro, ultra pro maths, right, in these concepts. And if your these concepts are right, then one lecture more I'll take of naming reaction and distinguished test. I promise you, you will get full marks in organic chemistry, right? Okay, yes. Let's start it. 1 hour to beta, I am not a magician, right? Okay, so to complete all of this, I at least need 2 hours. If you want to be pro in this, 1 hour will be, I'll be joking to you, right? Because I'm also gonna do some questions here, right? So for questions, see, just telling you the concept, nah, right? You have to do the questions also, right? Okay, let us start. Firstly, beta, we are going to start with these effects: inductive, mesomeric, aromaticity, back bonding, hyperconjugation. Then these things will be very simple for you. So let us start with these effects, right? Okay. So to make the lecture fast, to save your time, because we are very near to NEET 2025, what I have done is I have already collected the pre-written notes here. So that more, what you need to do here is, ma'am, do I need to write something here? No, you don't need to write anything here. All you need is to open your brain and understand whatever I am telling you, right? Okay, why I'm saying, because notes, I'll provide you these notes. Okay, these notes will be there in the comment section, in the description box. So no need to write anything. Carry one pen and one rough notebook so that you can, whenever I am teaching you, you can write something and that will be stick in your head for a long time, right? That's it. Carry a rough notebook, no fair notes you will make in this lecture, right? Okay. So now starting with the electron displacement effect. So basically we have temporary and permanent effect. Temporary effects are electromeric, inductomeric. Inductomeric is not in our syllabus, so you need to worry about that. Electromeric, right now, yes, they are asking questions on electromeric as well, right? Permanent effect are like inductive, hyperconjugation, resonance, or mesomeric. So I'll also tell you the difference between resonance and mesomeric in the end, right? So now, what is the difference between inductive and temporary and permanent effect? So let us see that. Whenever I say it is a permanent effect, it means that it does not depend on the external reagent, right? You don't need any external reagent to act for the displacement of electrons, right? So here for a temporary effect, some external reagent will attack here so that electrons will be displaced here. Then the electrons will be displaced. That means the electron displacement is happening in the presence of some external reagent, that is temporary effect. Permanent is we don't need any external effect here. It is in the compound itself, right? For example, it's inductive effect, right? Inductive effect happens because of the electronegativity difference of two atoms who are attached with the covalent bond. So here you have electronegativity difference. So these electrons are basically towards the electronegative element, right? So here we can say this is a permanent effect. It does not depend on the external factor, external reagent, right? It is within the molecule. So that is the difference between temporary and permanent effect. For temporary, we will understand electromeric, which is a very simple. Now for permanent, we have three very important effects, that is inductive, hyperconjugation, and resonance. Inductive, hyperconjugation, and resonance. On the first go, we will see inductive effect. Before that, this is what I have taught you already, right? Inductive effect. So beta, as I told you, inductive effect, right? First question, very simple. It is due to the displacement of sigma electrons, not pi electrons. Sigma electrons, you have a bond, let's say this is A, this is B, because one is more electronegative, other is less electronegative. So this shared pair of electron will be towards one side. Because of that thing, we can say there is inductive effect. Ma'am, but because of this electronegativity difference, how can inductive effect appears? Right? So let us understand this with the help of this diagram of distortion. Okay. So this is carbon and carbon. There is no electronegativity difference. But when we talk about this carbon and halogen, because halogen is more electronegative, so it will pull the electron towards itself, right? That is why more electron density will be towards the halogen, right? So this is distortion or displacement of sigma electron, which is called inductive effect, right? To be more clear on this, if you talk about carbon and halogen, देखो बेटा, just like we always take hydrogen as a standard, right? Even in case of electrode potential, we take SHE, that is standard hydrogen potential, right? So now here also we are taking carbon with hydrogen, right? Then carbon with some electron donating group, carbon with some electron withdrawing group, right? Carbon, if you talk about with hydrogen here, carbon with some electron donating group, which is giving the electron, what will happen? Earlier the electrons were present here. Now the electrons are present here because it is giving the electrons. So that is why electrons are pushing towards the carbon, right? So this difference appears because of the electron negativity. That is nothing but inductive effect. If you talk about electron withdrawing group, it is going to take the electrons, it is going to pull the electron towards itself, and that is why there will be displacement, that is delta X of the electron. Understood why it is called distortion, why it is called displacement, right? Now let us see some features of this. Relative effect or permanent effect, right? It is comparable effect. It depends on the electronegativity of the atoms. So it is relative and it is a permanent effect. Reference is hydrogen always, right? Here we have taken hydrogen as the reference, right? Then due to electronegativity difference it happens. It is unidirectional. Electrons will move towards one direction, the one which is more electronegative, right? It is irreversible effect. You can't say that you will just pull out the atom and it is irreversible. Then it will, the electrons will move towards the previous direction, right? So it is irreversible effect. We can't change it. We can't change this effect, right? Now let us see with distortion with distance what happens. This is a very, very important point. Then when we talk about distance, as the distance increases, the inductive effect decreases, right? It's like you and your friend who are like very close to each other. So when you and your friend are very close to each other, right, you are sitting next to each other, you guys can, like, you have a very strong bond. So as we say that this is long distance, okay. So as you are moving apart, so this inductive, the force that that is applied here, that is decreasing with the distance, right? So decrease with the difference, distance, right? Now, according to Ingold conversion, we have two types. One is plus I, one is minus I. Plus I is electron donating group. Minus I is electron withdrawing group. That is pulling the electron towards itself. Now, if you talk about the electron donating groups, you should know what are the different electron donating groups here. Okay, understood? Yes. Let us see the different. Now from here starts our question part. Directly from this series also they can ask you the questions, right? That which is more electronegative, right? Which has more electron donating power. So remember, if we talk about the one which has electrons, okay, electrons, let's take it as money. Okay, the one which has more electrons will have more power to donate the electrons, right? So it has negative charge, this has negative. That is why it has more power to donate the electrons here, right? So all the negative charge, and if you talk this thing here, this is carbon, this is nitrogen, this is oxygen. So what exactly happens here? Why this is in this order? Reason is oxygen is more electronegative. So it will not be very interested in donating the electron. Nitrogen as compared to oxygen is less electronegative. So it is more interested. See, if I am very clever, I don't want to give the electrons, right? So oxygen is more clever. It does not want to give the electron. But nitrogen as compared to oxygen is less clever. It's like, okay, I have electrons, you can take. But carbon is even too sweet. He's like, hey, you don't want electron, even then I'll give you the electron, I'm that sweet, right? So here, according to the electronegativity, this is the order, right? Okay, why ma'am then oxygen here it is even less? Because this oxygen, if you talk about, this oxygen is also there in the resonance here, right? So electrons are also shifting to this side. That is why it has even less inductive effect, right? It does not want to donate the electrons, because the electrons are already occupied in the resonance, okay, that are already there in the resonance, right? Next is talking about, this is your 3 degree, this is 2 degree, and this is 1 degree, right? This is also 1 degree, right? So according to 3 degree, 1 degree, 2 degree, this has maximum donation, less donation, even less donation, because one methyl group, here you have 3 methyl groups, so maximum. 2 methyl group less, 1 methyl group even less. Now there is just CH3, that is even less donation power. Out of these isotopes, tritium, then deuterium, then you have hydrogen, one isotope. Okay, right? Okay. Let me see how the live watching decreased like that. And first you tell me that. Ma'am, we want lecture on organic chemistry, then ma'am, we will not join. I don't understand that thing. Huh? I don't understand that thing. Ma'am has prepared so much for you. So many good questions I have taken up for you. Ki chalo, these guys are interested in studying organic chemistry. Then you say, ma'am, we don't have any, ma'am, we hate organic chemistry. It is a tension, this, that. Because you don't want to study only, right? So that is a very, very bad thing. That if you don't want to study, then tell me that, right? Then I should not be standing here taking up organic chemistry again from GOC, the important concepts. Right now, everyone will teach you name reactions. What I am teaching you, this, right? Why? Because that is a big, that you are actually fooling yourself that by just doing naming reaction, you will be able to do organic chemistry. It is NEET, it is not a board exam, right? That you can just by naming reaction, you can crack organic chemistry, right? Okay. Let me see why the Janta is not there. Wait a minute. Okay. I know you guys need this lecture. I'm not gonna go anywhere, guys. So it was just an alert that I gave on the Telegram channel. Okay. Now let us see. Wait a second. Wait a second. Because I don't want, because I'm not gonna do this lecture again. Na? So if you demand this again, I'm not gonna do this. Right? It's today only I'm picking up this. Right? Now, next is factors. Okay. So now once you know the plus I series, how it is, then you should know the factors that are affecting. So always remember anion is always going to be more as compared to neutral. Anion should be more as compared to the neutral. Then branching, if you talk about the branching, more is the branching, more is the plus I effect, right? Next is, if branching is same, then that depends on the number of carbon. Like here, the branching is same. Okay, branching is, this is also 1 degree, this is also 1 degree. But here you have 2 carbons, here you have 1 carbon. So it depends on the number of carbon if you have the same branching. Okay, so these are the 3 important factors on which plus I, that is electron donating group, depends. Okay, understood? Is this part clear to everybody? Now next is minus I. Okay, for minus I, what you have to do? So for minus I, simply what we will do here is, this is NF3. This is a very, very, very important conclusion, that NF3, then you have NR3, then you have NH3, right? After this, you have NO2, SO3H, CN, CHO, COH, then all the halogens, right? So this basically forms the series here. Out of this particular thing is very important. Then OR has greater minus I effect as compared to OH. Then SH has greater minus I effect as compared to SR. This is the total series of minus I electron withdrawing group, right? Okay. Now, next students, according to inductive effect, if you talk about the inductive effect, how you will tell, this we'll talk about later only, right? Right now, just focus on carbocation and carbon ion. Chalo, let's focus on that as well. Acha, always remember, it's a very, very important thing that whenever they ask you, because everything is interrelated with each other, okay? So whenever they ask you, if you talk about carbocation, always remember carbocation is like money. So I want everyone to write it down in the comment section. Carbocation is like money, right? So if you are, if someone gives you money, then you will be very happy, you will be very stable. If someone takes out money from you, you will be very unstable. But carbon ion, that is like stress. So if someone gives you stress, you will be very unhappy. If someone takes out stress from you, you will be very happy. Right? So just remember, carbocation is money, carbon ion is like stress. So basically, ma'am, what you are talking about donation and taking away. So donation is electron donation by anything, right? And when you're taking away the money or taking away the stress means when you have electron withdrawing group. So that simply means that for a carbocation, the plus effect, right? Plus effect makes it stable, minus effect makes it unstable, right? But opposite is for carbanion. If you give the plus effect, that means you give the donation here, that is making it unstable, but minus is making it stable. So that means you can also remember it this by this. For carbocation, you need plus. Means for plus, you need plus. That means for carbocation, you need any donation. But for minus, you need minus. That means when you have carbanion, you need electron withdrawing group to make it stable. What is it? Plus, plus, minus, minus. Understood? Plus, plus, minus, minus. If you want to understand by money and stress, you can understand by money and stress. Or remember plus, plus, minus, minus. That is clear. Okay. I'll again repeat this. Right, very simple thing. See, if you have carbocation, that is like money. If someone gives you money, donate money, you will be happy, you will be stable. If someone takes away money, you will be unhappy, you will be unstable. That's why you have taken money from me. Now, if someone is under stress, so if you have some friend who is giving you more stress, that you have not studied that, you will be very unhappy, you will be unstable. If you have a very good friend who is like, okay, don't worry, you have Diksha ma'am, you have Vedantu NEET English with you, right? Go and study there. So that is making you, that is taking away stress from you, right? So that is making you stable. Or you can remember this by plus and plus. For carbocation, you need electron donation to make it stable. For minus, you need minus. That means for carbanion, you need electron withdrawing to make it stable. Right? Okay? Yes. Right. Okay. Now, next is some important factors about some important things in which they can confuse you here. Right? So, in which they can confuse you, let us see some questions here. That is, first one is, let us see, they have given you these two carbocations, right? For carbocation, positive, you need positive. That means for carbocation, you need donation, right? More is the donation, more is the stability. So here you have this chlorine, here you have this fluorine, right? I told you that always with the distance, inductive effect will decrease. So here you have two factors. One is this distance. Here you have less distance. Here you have more distance. One is that fluorine is more fluorine is more electron withdrawing as compared to chlorine. So which one you will select? You have two factors. You have to select one out of it. So here it is strong group but far away is weaker than weak group but nearby. That means here distance will dominate. Very, very important. That distance will dominate. Distance is going to say that yes, you should select me. So it doesn't matter if fluorine is a stronger electron withdrawing group. It doesn't matter if fluorine is far away from you. Right? So chlorine is near to you. Right? That is why chlorine will have more impact on you. So here it is chlorine. Distance will dominate here. That is why chlorine, which is a weaker group, still it is more effective here. That is why here what will make it. So we will operate it with the distance. Here you have less distance. That is why more inductive effect, more minus I. That is why this will be unstable. Because for carbocation, you need positive, you need electron donating group. Right? So here, this is also electron withdrawing, but this is having a distance, okay? This distance. That is why this will have less effect. That is why this one is more stable as compared to A. Got it? Very important. Distance will dominate over the strong or weak minus I or plus I group. Right? Next confusion is, if they ask you, if you have like this carbocation, this is the carbocation. Here you have fluorine. Here you have two chlorines, right? One you have fluorine, other you have two chlorines. So what is important for you here to note down, that when you talk about fluorine, ma'am, fluorine is a stronger electron withdrawing group. But I am saying here you have two chlorines. Now which will dominate? weaker multiple group will dominate as compared to even if you have single strong group. No, it will not dominate. If you have Khali, right, and you have thousands of Chintu Mintus like us, right, then definitely we are going to dominate more, right, because the number is more here, right. So here number will dominate. So this will have more minus effect. That is why it will be less stable as compared to this, because minus effect makes the carbocation unstable. Got it? Understood? Right? Okay. Okay, yes, Malika, it will fade away after 4 carbons, right? So, when you talk about inductive effect, as the distance operates, as the distance increases, it will like fade away, right? So, that is the reason. Now, next is resonance. Before resonance, let us do some question based on inductive effect. Let us see if you are able to solve that or not, right? So, every time we are going to do something, we are going to do questions based on that concept. Okay, so these are the questions of inductive effect. Now we have the test part for you. I'm not going to load you with the questions in the end. That we will not do. Firstly, we will do some concept, then question, concept, then question, concept, then question. This is what we are going to do today. Right? Now, this already I have taught you. This effect already I have taught you. This also I have already taught you. This is very important. This is very, very important. Okay, so you must know these two effects, right? So depending upon that, how you got the question, let us see. First is, which of the following belongs to plus I group? Okay, which of the following belongs to plus I? Plus I means which will donate the electrons here. Anybody in the comment section? We have just done this, right? These are your previous year questions only. So everybody, so what about this one? Which of the following belongs to plus I group? Plus I means electron donation is there in which of the following, right? A, B, C, D. Here this has lone pair of electrons. This is CH3. This is positive. This has negative. This also has lone pair of electron, which is there in plus I. But I am not talking about resonance here. I am talking about plus I effect. Very good. That is C is the correct answer. This we have seen because of this negative charge, it is going to donate the electrons through the plus I effect. Next is the inductive effects of the group. Now these are the groups they are talking about. The inductive effect of the following is. If you talk about NH3, then deuterium, then CO2 negative, then COH. Right? You have to tell about the inductive effect here. Which of the following has which inductive effect? Right, everybody? NH3, positive. It is going to take away the electron or donate the electron? The one which is electron donating, right? It is going to, it has less electron. It is deficient in electrons. It is going to take the electron. So this is definitely minus I. So these two are already eliminated here. Next one is deuterium. This we have seen that this is plus I, right? Then next one is CO2. Again, this will donate the electrons because of this negative charge. Then you have COOH. This we have seen in minus I group. So answer is going to be A is the correct answer. Very good, everybody. A is the correct answer. Very good, very good. Now, let us talk about the next concept here. That is resonance, resonance, resonance. Okay. So what is resonance? Anybody in the comment section? What is basically resonance? What we talk about in resonance? So resonance, when we talk about resonance, we talk about the delocalization. Beta, delocalization of pi electrons. Inductive is distortion or displacement of sigma electrons. Right? So this is delocalization of pi electron. It is the most important concept here. Very, very, very important. So always remember here only the pi electrons are going to get displaced, right, from its position. So exactly what will happen? Like here you have C double bond, C single bond. This is negative. So what will happen? Negative charge will get converted to bond pair. This pi electrons will get converted to the negative charge. So basically what has happened here, if you see this clearly, that one thing is all the nuclei are on the same position. All the atoms are on the same position. It's just that the change that we can see is in the pi electrons. These pi electrons are shifted here and there. So that is why it is called delocalization, or delocalized means, see, delocalized. If you are living in one locality, I'll say you are localized. If you are delocalized, you don't have any home. You are sometimes here, you are sometimes there, right? So we say this particular person is delocalized. So this electron that is moving here and there in different resonating structures, that is called delocalized electrons, right? Now, to understand this more clearly, I have some important points for you to remember. Right? One thing is, always remember the different resonating structures that we are forming are called canonical structures, and there is one resonance hybrid that we have formed combining, which will represent all the different resonating structures. But the resonating structures are hypothetical, they are imaginary, right? In real, the distortion of electron, see, if you talk about this place, in real, what is exactly the resonance hybrid? The electrons are same, the sigma bond is as it is. The pi electrons are moving in this direction also, in this direction also. Negative charges here also, negative charges here also. So this is the resonance hybrid that we have. These are the two resonating structures that we have, and resonating structures are imaginary, right? Next important thing is resonance hybrid. From here, how they can ask you the question, which of the following about resonance is true, right? So this question they can ask you. So for that, resonance hybrid is greater, has greater energy as compared to the resonating structures, right? Okay, then let us talk about this bit. I have already told you that only pi electrons and unshared electrons like lone pair, free radical, negative charge, that will be displaced here and there. Actual structure is average of canonical structure, maximum number of valence, all this you don't have to do. Position of nuclei will not change. Canonical structure has same number of unpaired electron. All atom must be planar, right? That means they should be in sp2 hybridization. Now, to understand this more clearly, you have to divide it according to three parts. One is double bond and p orbital. Next is alternate double bond. Third is back bonding. Three kind of resonance that will sum up everything here. One is double bond and p orbital. Double bond and p orbital means here you will always have a double bond, a single bond, and a p orbital. Right now, understand this very carefully. Double bond, single bond, and p orbital, because some question they are asked, which of the following will not show resonance? For that, you need to know the conditions of resonance. Okay, so double bond, single bond, and p orbital. If this is empty, this p orbital is empty, that will be called carbocation. So that will be double bond, single bond, and carbocation. If you fill one electron here, that will be called as free radical. So we can see that double bond, single bond, and free radical will also show electrons, will also show resonance. If you have two electrons here, that either can be lone pair or it can be negative charge, that will also show resonance, right? Now the difference in lone pair and the negative charge. What is the difference in lone pair and negative charge? Very simple. Beta see, if you talk about negative charge here, if you talk about negative charge, if you talk about lone pair, exactly what happens if this is A, this is B, right? So, for example, this is A, this is B, this is also A, this is also B. This is A, this is B. If I say this is lone pair, that means both the electrons are of B only. Okay? So, these two electrons are coming from B only. This is from the atom of B only. But if I say this is a negative charge, then what must have happened here? There must be some bond here. One is the electron of B, other is the electron of A, and after that, what must have happened here? It had got all both the electrons with itself, and now it is having two electrons, but one electron is of B, one electron is of A. That is why we say this is a negative charge. Okay, that is why we say it is a negative charge. So that is the difference between negative charge and lone pair, but in both the cases for this p orbital you have two electrons. Got it? Understood? That is the core thing about, see why I'm telling you this, because when we are doing the resonance, then you should know the difference between lone pair and negative charge, right? Okay. Now let us see, this I have told you, empty means positive, carbocation, 1 electron radical, 2 electron negative or lone pair. So let us see all these 4 cases, how we do the resonance. First is with the carbocation, if you have double bond, single bond and carbocation, right? Okay. Now beta, very simple how you will do this. Here we have done firstly double bond, single bond and lone pair is the first that we are doing here. So first is double bond, single bond and lone pair. What is the trick here? Lone pair is converted to bond pair to negative charge. Okay. Lone pair is converted to bond pair is converted to negative charge, and you can see here also overall molecule is neutral. Here also overall molecule is neutral. You have 2 pi electrons, you have 2 pi electrons, right? Okay, overall molecule is neutral molecule, lone pair to bond pair to negative charge, that is for lone pair, double bond, single bond, lone pair. Second is, if you have, these are the examples, lone pair to bond pair to negative charge, this is what we have done here, right? Okay, now remember this thing here, when this is shifting, when someone is, see, you have 20 rupees of your own, you have to give the electrons to someone, right? Then what you will do, you will feel very, like, you will feel, I'm very poor. I had 20 rupees, I have to give both 20 rupees to my little sister or brother. They'll feel very sad. You will feel like, oh my God, I am very electron deficient. I am feeling very poor, right? So that is why this X will feel poor. That is why there will be this positive over here. This carbon, it's like these 2 electrons were actually shared. Now I have both the electron. That is why it is rich in electrons, right? It has negative charge, right? Now, second is you have double bond, single bond and negative charge. Here what you will do, negative to bond pair to negative. Negative to bond pair to negative. What we will do, negative to bond pair to negative. Let us do that. Okay. So negative to bond pair to negative. Other things are going to remain same. Sigma bond is same. Nuclei are all at their own position that they were before. So you don't change any atom position. You don't change any sigma bond here. This is negative to bond pair to negative. Here we had lone pair to bond pair to negative. Okay. Understood? Next is double bond, single bond and carbocation. Now this carbocation is empty here. So what will happen here? What will happen if I say double bond, single bond, negative? This is the double bond. Okay, this is showing sideways overlapping. This electron will jump here. This will become positive. This will become carbocation. This will become double bond. Understood? Earlier, this is the double bond. This is the positive charge because this is empty. Now this electron will jump here, right? This electron is empty. So this will be a positive, this will be a double bond. This is what we are doing in reality. And what we have to remember for the exam, that here what is converted, this pi bond has shifted here. And from where the pi bond has shifted, it will have a positive. So that is why here you have a positive, here you have a pi bond. Okay, understood? Last one is free radical. Free radical is same as carbocation only. So here what has happened, this pi bond will shift here, right? Here you will have a free radical. Basically what has happened, homolytic cleavage will occur here. One electron will jump to this position, this will form a pi bond. One electron will stay here, this will be a free radical, right? So it is same as carbocation, right? Okay, 4 things we did. One is, everybody, 4 things we did, right? I'll just write it in the end, right? 4 things we did here, beta. 4 things we did here. 1, 2, 3, 4. First is lone pair to bond pair to negative charge. Lone pair to bond pair to negative charge. Negative to bond pair to negative charge. Right? Here pi will jump here and here you will have positive. Here this electron will jump in this position and here you will have a free radical. Understood? Is there any problem for these 4 resonating structures in the end? Is there any problem? Will you be able to do the resonating structures? Because these are the questions that they will ask you, right? These are the questions that they will ask you in the end. Now, next is alternate double bond, single bond, right? Next category is alternate double bond, single bond. That means like this, double bond, single bond, double bond. Here, what will happen? So this pi bond will jump here. It will have negative. This pi bond has jumped here. And from here, this will have a positive. So basically what has happened here, because the electrons are moving, so this pi bond will jump here in this position, right? This pi bond will jump here, from where you can see one new pi electrons are jumping on this carbon, it will have negative. From this carbon, you are taking away the electrons. So this will have a positive charge. It will be electron deficient. Okay, this is the resonating structures of double bond, single bond, and alternate double bond, single bond. Next is back bonding. Third category of resonance. Third category of resonance, that is back bonding. Now in back bonding, one should be electron rich, other should be electron deficient, right? So if we talk about this thing, this is electron rich, this is electron deficient. So the electrons will jump here. This will have a pi bond, because from here whenever you are taking away lone pair from something, it will always have a positive charge on it. So you're taking away lone pair from this side, so it will have a positive charge. Here earlier it was electron deficient, but now you have given it the electrons with this double bond, so it is now neutral. Okay, so this is back bonding. Back bonding can also occur like this: electron rich, electron deficient. Same way, electrons will jump here. Positive charge, pi bond. Back bonding can also occur in this particular state. Can you see this here? Very, very important. If you see this, this is sulfur, sulfur, this is negative charge. Okay. So here, electron rich, electron deficient, electron rich, electron deficient. Can you tell me why sulfur is electron deficient? Anybody? See, this concept is from inorganic chemistry, right? That if you talk about the elements of second period, like sulfur, chlorine, the second element, you can say the second element of all the groups, right? Like sulfur, chlorine, they are vacant d orbitals. The first element does not have vacant d orbital. Only boron is that first element that has vacant d orbital, right? Because it has electron deficient, because octet is not complete in case of boron. These two concepts, we took this from inorganic chemistry, P block, right? If you apply this concept here, because this is electron deficient, this is electron deficient, so it will cause back bonding. This is electron deficient, this is electron rich, this will cause back bonding. This is electron deficient, electron deficient, electron deficient, this is electron rich with a negative charge. It will also cause back bonding here, right? Okay. So this is how inorganic chemistry and organic chemistry are related to each other. Now one more kind of question from resonance that is why I told you resonance, first kind of question that they ask you is resonating structure. You have to make the resonating structure. Second kind of question is, which of the following resonating structure is most stable? Which of the following resonating structure is least stable? So depending upon the stability of resonating structure. So how you will tell the stability of resonating structure? First is, always remember, neutral is more as compared to charged. So if any of the resonating structure is neutral, that is more stable as compared to the charged. So, and always you will go one by one. First you will see the neutrality, then you will see if all of them are charged, okay? Then what you will see, that stability will be according to the number of pi electrons. More the number of pi electrons, more will be the stability here, okay? More the number of pi electrons, more will be the stability here. Okay, students? Got it? Now, next is, ma'am, if the number of pi electrons are also same, then what we will do? Negative charge is more stable down the group and along the period. Okay? Negative charge is more stable down the group and along the period. right? Reason if they ask you, right? Where's the reason in organic chemistry, they will not ask you, but for inorganic chemistry, they can ask you, right? Why here negative charge is more stable along the period? Because electron negativity is increasing. But in case of down the group, because size is increasing, that is why negative charge is more stable. Last one is, if there is no comparison of negative charge on more stable atom also, then last one is more charge separation give rise to less stability, right? If you have charge separation, that means if you talk about this and this, here charge separation is less, so it is more stable. Charge separation is more, so it is less stable. Okay, understood? Got it? Charge separation is less, so it is more stable. Charge separation is more, so it is less stable. Understood? Got it, beta? These 4 points. According to these 4 points, you have to tell the stability of the resonating structures. Okay. Last question that they can ask you. First is, what is the difference between resonance and mesomeric effect? Okay, that they will not ask you, but you should know that. Why we can replace M with R here. See, if you have resonance in benzene, okay, like here you have resonance because of the pi electrons. If you talk about any double bond, single bond also, here resonance is because of the pi electrons. So resonance does not occur because of some external atom that is giving or donating or withdrawing the electron. Okay. So this is resonance, this is the resonance. But if you talk about mesomeric, these two are not mesomeric. This is not mesomeric, this is not mesomeric. Mesomeric always happens if you have some electron donating or electron withdrawing group here. So very simple trick I'll tell you here, right? So guys, if on the benzene you have a group that has lone pair of electrons, then always it is going to donate the electrons. Always it will be plus M or plus R effect, right? Okay. But if you talk about, if you have a group that is may or may not have electrons, lone pairs, but it is singly or doubly bonded, not singly bonded, it is doubly or triple bonded to more electronegative element. That means if it has pi electrons with pi bond with some more electronegative element, then what will happen? This electronegative element, it is very clever, it is going to take away the electron. Then this atom is going to take away the electron from the benzene ring, and hence it will show minus M or minus R effect, right? So the simple thing is, if you have on the benzene ring, you have a group that is having lone pair of electron, it will donate the electron, will show plus M or plus R effect. That is why, right, it is ortho. Chalo, that we will not do. Simply just learn one thing, that if you have a group attached to benzene ring which has lone pair of electron, it will show plus M or plus R effect, right? If you have a group that is double bond or triple bond with more electronegative element, then it is going to show minus M or minus R effect. Okay. Now, very simple. This, so basically it is more important when you talk about subjective exam, but what is the important part that you can take out from here? So this is how resonating structures you will produce. Lone pair to bond pair to negative charge, right? Then this is negative charge to bond pair to negative charge, right? Again, negative charge to bond pair to negative charge, right? Negative charge to bond pair to negative charge, negative positive become neutral, right? Now, if you see all these resonating structures here, you can see that on ortho position, on para position, you have the negative charge. On ortho and on the para position, you have the negative charge. So for electrophilic substitution, when you have an electrophile, that is electron loving, that wants electron density, it will attack on ortho and para position. Always para is going to be the major product, right? Unless and until you have any hydrogen bonding. This is what you will use in the reaction part of organic chemistry, right? Reaction part is incomplete if you don't know these things, right? So if you talk about this, this is the resonance hydride, ortho para negative electrophile that will attack on ortho and para position, right? All group which shows plus M effect are ortho para directing groups. Okay. Next is, ma'am, if you have some electron withdrawing that is showing minus M or minus R effect, then what will happen? Now, beta, this is the nitrogen, right? It is double bonded attached to some more electronegative element like oxygen here. So, what will happen here? It will take out the electron, it will take out the electron from this side, it will show minus M or minus R effect, right? So, when you draw the resonating structures, what you will see, there is positive charge on ortho and para position. Now, ma'am, what we have to use from here? That means an electrophile, which is electron loving, that wants to see which has more electron density. So, where you will see more electron density? You will see more electron density on meta position. This is the meta position. So, you will say it will attack on the meta position. It is meta directing. Okay. Now, last part is, this is all group showing minus MR meta directing. Now, beta, these are the examples that I have shown you, the very simple examples, that plus M are all the groups that has lone pair of electron and don't have double bond with any more electronegative element. These are all the groups that are double bonded with more electronegative, double bonded with more electronegative. Okay? Double bonded with more electronegative. Right? So that is the reason all these are showing minus M effect. Right? Understood what is the concept of ortho para directing and meta directing? Right? Okay, beta. Must be a lone pair and a vacant orbital. What, Amrita? Is there any problem? Back bonding in cyclic ring. Back bonding in cyclic ring. There must be one electron withdrawing and electron donating element there. Right? Okay. So, activating and deactivating, it will not, we can't say if this is minus M, it is activating or it is deactivating. That we will tell from the overall effect. Always mesomeric is more dominating. So we always answer it according to mesomeric, right? That if you talk about activating, the one which is donating the electron. So all the plus M effects are going to be activating. All the minus M effects are going to be deactivating, because mesomeric is more dominating as compared to inductive effect always. But here, if you talk about plus M, in case of halogens, see, usually mesomeric is more dominating as compared to inductive. That is why plus M means activating, minus M means deactivating. But in case of halogen, what will happen? Inductive is more dominating as compared to mesomeric, right? So that is why here halogen, because of the electronegativity, it will show minus I, but because of the lone pairs, it will show plus M. Usually plus M is more dominating, it should be activating. But in halogens, minus I, that means inductive is more dominating, so it is deactivating group. Very important question, that halogen is showing ortho para directing, it is plus M, but it is still deactivating in nature. Right? Okay. Understood? Yes, students. Sure. Okay. From here, one important question from the reactions only. So I'll tell you what I told you in the starting. Today, lecture is completely on concepts of organic chemistry. You will see all these concepts are answering your organic reactions also. So see, this question you must have seen in, if you have practiced enough, you must have seen this question somewhere, right? So now here we are saying that rate of reaction, if you talk about, this is also plus M, this is also plus M. So both are ortho para directing only. But if you talk about the rate of reaction, it is more in case of OH as compared to Cl. What is the reason? Because it is activating, it is deactivating, right? Okay, this is activating, this is deactivating. That is why rate of reaction is more in phenol as compared to halobenzene. Okay, Yes, students. Any problem? So I'll conclude this in the end. I'll conclude this in the end here. Again, I'm concluding this. If on a benzene ring you have a group, an atom that has lone pair of electrons, it is going to show plus M or plus R effect. Right? Usually plus M and plus M are always ortho-para directing only. So you can write ortho-para directing. Right? Okay, chalo, I'll just write it here, ortho-para. This is meta. Chalo. If on a benzene ring, you have a group that has lone pair of electrons, it is going to show plus M or plus R effect, that is ortho-para directing towards electrophilic substitution reactions. If on a benzene ring, you have a group that is pi bonded with some more electronegative element, that it is going to show minus M or minus R effect, which is going to be meta directing towards electrophilic substitution reaction. But here, if you talk about activating and deactivating, usually plus M groups are activating in nature, minus M are deactivating in nature. It is going to take out the electrons. But for halogens, it is ortho-para directing, but it is deactivating because it is showing minus I effect, which is more dominating. In case of halogen, usually inductive effect is less dominating, but in case of halogens, you have inductive effect which is more dominating. That is why it is deactivating in nature. Understood? That is the conclusion of what we have studied in next 4-5 slides. Okay? Now let us do questions on resonance. Let us do questions on resonance. A lot of questions we have on resonance, right? So are you all ready for questions based on resonance? Okay, are you all ready? Everybody, are you all ready for questions based on resonance? Yes. Now, let us see the questions based on resonance one by one, and I want all of you to answer this, right? Not much time it is going to take. This is the effect that I have already covered, right? Okay. Starting with the first question on your screen, which of the following molecule is least resonance stabilized? Okay. Least resonance stabilized. See, if you talk about least resonance stabilized, it is also showing resonance. It is also showing the same kind of resonance. This one, if you talk about, this is also complete resonance. I think this is based on least resonance stabilized now. Okay. So we can see the number of pi electrons, not even pi electrons, we can't see that, right? Resonance stabilized, they are saying now. So if you see this here, this is lone pair, this will jump here, it will jump here, right? Then this will be negative charge, then this will jump here, this will jump here. Again, it is showing resonance. But in this case, if you see double bond, single bond, double bond, double bond, single bond, double. Right? Very good. D is the correct answer. Can you tell me why? There is one more concept, right? Always remember that if you talk about one is cross, one is extended. Or you can say extended and cross resonance, cross conjugation. See, it's like, what is the difference between extended and cross? Firstly, let us see, right? Extended is, for example, this is someone on a motorbike, right? So, in extended, what we have, that here, let's say this is a bike, okay? I don't know how to draw a bike. I'll draw a car. No, I'll draw one bike only. This is a bike, okay? This is another bike. Okay, so here one person is sitting, here second person is sitting, here one person is sitting, right? Arey, what is happening? I don't know why it is changing by itself only. Let me show you firstly some example. Arey, some bhoot has arrived in my studio. I am not writing anything, but it is writing by itself only. Let me give you some example, guys. Some example. Extended, and this is cross. Okay. So let's say this is 1, 2, this is 3. Okay. This is one thing. Other you have, let's say you have 1, 2, and 3. Okay. Or you can also draw it like this. If you see this thing here, here lone pairs, then lone pairs will shift here, this will shift here. That is an extended conjugation, right? Because lone pairs are shifting, lone pairs are shifting, lone pairs are shifting. Now this cross means either it can shift to this side or this can shift to this side. Either it can have conjugation on this side or it can have conjugation on this side. That means it has a choice. So that is a cross conjugation. Always when you're working in one direction, that is more stable. It's as if, one example that I always give my students, and for example, you have extended is like you have one boat here, right? You have another boat here, right? And people are going here and there, right? So this one is going here only, this other guy is only on this boat. You don't have space here, so other guy is on this boat, right? So this is extended. So you guys are only in one direction, right? Cross is, this is one boat, right? This is other boat. My boat is little weird, right? So one guy is sitting here, other guy is sitting here, and one stupid guy is sitting in between. This you must have seen some people doing stunts here. One leg on this side, one leg on this side, right? So this guy that you can see here, one leg on this side, one leg on this side, will he be able to survive? He will die, right? So that is cross conjugation. So when you have extended conjugation, that means you are just going in one direction, right? You are not like, I want to be here also, here also. That is not going to have, that is not possible, right? So for extended, you are going in just one direction, right? That means you are just taking part in one thing, right? Extended, which is more stable, which is going to give you more stability. If you focus on like, I want to be in this boat also, I want to be in this boat also, that is like a cross conjugation. I want to donate electrons here also, here also. Then you will definitely die here, right? Okay. So this one is not stable, this one is stable. So this is what you will see here. This conjugation is on both sides. Either this can go to this side, either this can go to this side. That is why this is least stable, because of the cross conjugation. Got it? Right? Okay. It's me, the both. Then you have to shift to one boat only, right? So some students, they do na, I want to be an actor also, I want to be a doctor also, I want to excel in this thing also, that thing also. So what they end up doing is excel in nothing, right? So that you don't become that person, right? Okay. Next is resonance energy of these compounds will be in the order as. In which order the resonance energy will be, right? In which order the resonance energy will be, everybody? Which order? If you see this, the resonance energy of these compounds will be in which order? Yes. Lone pair here, lone pair here. Okay? Two lone pairs. Resonance energy, beta, you have to tell. If you see this, third will be the least stable because of the cross conjugation, right? Okay, so this is eliminated, this is eliminated, either 1, 2 or 2, 3. Now, if you see this, oxygen, so it has to donate the electron for the resonance. Oxygen, it will find it difficult to donate the electrons, right? Nitrogen, this is less electronegative, so it will find it easy to donate the electrons here, right? So this will have more resonance in it. These compounds will be in the order, so that is going to have more resonance energy. No? So answer should be 1, 2, 3. Yes. So answer is B. That is 1, 2, 3 is the correct answer. Okay. Okay, ji. Answer is 1, 2, 3 is the correct answer. That is B is the correct answer. This nitrogen, it wants to donate. It is like as compared to oxygen, I am a good person, right? Here, because of the cross conjugation, it is also going to this side also. So it will be least stable here. So answer is going to be B is the correct answer. Is that clear? Okay. Is that clear? How, ma'am? Acha beta dekho. If you talk about resonance energy, means they are asking you the order of resonance only, which species is more stable. So here, because of the cross conjugation, lone pair, double bond, single bond, lone pair, it can shift to this side, electrons can jump here. What can happen? It can shift to this side, electrons can jump here. This is a cross conjugation. So cross conjugation is always less stable, right, as compared to extended. Here also you have extended, lone pair to this side, then this side, then this side. Then here you will have negative to this side, then this to this side. This is extended, this is also extended. So third is going to be least stable. If you talk about 1 and 2, then beta, nitrogen, it has more, nitrogen as compared to oxygen has less electronegativity, means it is not very clever. So it can easily donate the electron as compared to this oxygen, which is more electronegative. That is why first is maximum, then 2, then 3. Is that clear? Okay. Okay. Yes. Okay, chal. Next we have which of the following compounds will not show any resonance. So if you see this here, which of the following compounds will not show any resonance here? Very simple. Okay. This can also show positive, single bond, double bond, then single bond, double bond, single bond, double bond, single bond, positive. This will show resonance. Double bond, single bond, double bond, single bond, then also positive. This will also show resonance. All the conditions. It has a resonance, then single bond, double bond, single bond, positive. This will also show resonance. This also full resonance, but here you have nitrogen, which is very electron deficient here, right? So this species is not applicable for the resonance, right? So answer will be this one. So answer is going to be C is the one which is not showing any resonance. So answer is C is the correct answer. Okay, sure. Next is which of the following is not a permissible resonating form? Permissible resonating form. Okay. Bitter nitrogen is less electronegative. Okay. Yes. Achha, let us see this thing here. Which of the following is not permissible resonating structure? What do you mean by permissible? That means which of the following is not possible only. Which of the following is not possible, beta? Can you see this here? Very simple. Beta, these kind of questions they ask you, okay? So this is the permissible. This I can see is not permissible. Right? Which one? You tell me. Nitrogen has 4 bonds, permissible resonating form. 4 bonds, but still it does not have any negative or positive here. It has 5. Wait a minute. 1, 2, 3, 4. So it should be positive here. Okay? It is wrongly typed here. It should be positive here. Okay? Because this is 1, 2, 3, 4, 5 bonds. Na? So 5 bond pentavalent nitrogen is never possible. Right? So C is the not possible resonating structure. Here it should be positive. Otherwise, so this is also not possible. If I say otherwise, this is also not possible if here you don't have positive. Right? So nitrogen with 4 bonds should always have positive charge. Okay? So next is among the following least stable resonating structure. Least stable. This is of the same compound. When you talk about the same compound, firstly let us see least stable. Okay? So nothing is neutral. All of them has how many pi bonds? 1, 2, 1, 2. 1, 2, 1, 2. So according to pi bonds also we can't answer. Positive charge is always there on nitrogen only, right? Okay. We can say two things here. What is the difference? Least stable they are asking, you know. If you see this, more charge separation, less stability. Less charge separation, more stability, right? Okay. According to charge separation, if I want to answer this, I can't, right? Least stable. Here oxygen has negative, oxygen has negative. This two is same everywhere. This is same everywhere. So we can't answer it according to this nitrogen. If you see this, here carbon has negative and positive charge. Here also carbon has positive and negative charge. Here carbon has positive and negative charge. Here oxygen has negative charge. So this automatically becomes maximum stable. So this is out already. If you talk about compare these three things, here what is similar, what is the difference? These three things, this is same everywhere. Okay, this is same everywhere. The difference is in the positive and negative charge. Positive and negative charges here, positive and negative charges here, positive and negative charges here, right? So which will be least stable? As you can see here, two positive charges on the adjacent position. Here, two positive charge are not on the adjacent position. Here, positive and negative charge are on the adjacent position. So, two positive charge can not be on the same position, right? So, answer will be A is the least stable. Understood how I answered it? Firstly, I had to find the difference. So, firstly, what I found that this is already eliminated because here oxygen is carrying a negative charge, making it the maximum stable, most stable resonating structure. Then here these three things are same. The difference is in the separation, right? Where we can see the distance of charge separation is same, but here two positive charges are on the adjacent position, which makes it less stable. So answer will be A is the correct answer. Got it? Right? Two like charges on adjacent atoms, therefore it is least stable. Got it, beta? Everybody? Yes, students. Now we will see hyperconjugation. Now, beta, we will see hyperconjugation, which is a very, very simple concept. You will find, ma'am, hyperconjugation is the most stable thing, most easy thing, right? Okay. Same charge, nearer have more energy, less stable. Very good, Karti, very good. So the third concept is hyperconjugation. See, first is I'll tell you directly. Hyperconjugation, it is a no bond resonance, Encke-Mer effect, Baker-Nathan effect. These are the different names that is given. Okay. So what are the two important factors that you should know about hyperconjugation? These conditions are alpha carbon should be sp3. Okay. So your alpha carbon, if I am talking about alkene, the carbon, see this is alkene, alpha carbon is what? This is the main group. The carbon next to the main group is alpha. This is the main group. The carbon next to the main group is alpha. This is the main thing. The carbon next to the main thing is alpha. So this alpha should be sp3 hybridized. That means this should be sp3 hybridized. And to that carbon, at least one alpha hydrogen should be there. That means on the alpha carbon, you should have at least one hydrogen atom. Otherwise, it is not going to show any hyperconjugation. Let us take an example here. This is the carbocation. This is the alpha carbon. This is alpha carbon. This is alpha carbon. All the alpha carbons are sp3 hybridized. But sp3 means it has 1, 2, 3, 4 sigma, 4 sigma, 4 sigma. So all are sp3 hybridized. But if you can see here, it does not have any hydrogen here. Alpha carbon, if it does not have any hydrogen, it is not going to show any hyperconjugation. So two important things, that is, it should be alpha carbon should be sp3, it should be sp3, then it should be having at least one alpha hydrogen. Okay. If you're done with these three things, then what are the different type of compounds where you can see hyperconjugation? One is carbocation, then free radical, then alkene. Carbocation and free radical are the same, but this is the orbital diagram. Usually they don't ask you this, right? If you want to do this, I'll just quickly tell you. But this thing you should remember to just to make you understand this thing. I'm teaching you this thing, okay? So if you see the orbital diagram, right? This is the sigma bond, sigma bond, sigma bond, sigma bond. This is empty carbocation p orbital, right? Here exactly what happens, why it is called no bond resonance. So basically what will happen, the electron, two electrons from here will jump to this side, right? So what will happen, they will form something like this. They will form a pi bond here, right? So basically the electrons from here will jump to this side. They will form a pi bond here, and this hydrogen will be left with a positive charge. So this hydrogen is having no bond with this carbon. This is not ion. This is no bond resonance. It is not having any bond because it is the bond we have is already not there. The electrons in this bond have shifted as pi bonds. So that is why this is called no bond resonance. So what they can ask you is from where the electron movement is happening. First is hyperconjugation happens in sigma bonds. And this is delocalization of sigma bonds. Delocalization means electrons are actually moving from one position to the other position, right? So here what you will see, sigma to empty p orbital, from sigma bond to empty p orbital it is moving in case of carbocation. Ma'am, do I have to learn the structures of hyperconjugation? No. What you have to understand is number of alpha carbon, alpha atoms, alpha hydrogen atoms will tell you the number of hyperconjugating structures, and more the number of hyperconjugating structures, more is the stability. A simple thing is more the number of alpha hydrogen, more is the stability. This is what you should remember. More is the number of alpha hydrogen, more is the stability. This is what you should remember for your exams. Okay, this is what you should remember for your exam. Now, if you see this here, number of alpha hydrogen are 3 into 3, 9. Number of alpha hydrogen are, this is 1 and 1, this is 2. So, which is more stable? This carbocation is more stable as compared to this carbocation, right? If you talk about the free radicals, okay? So free radical is same as carbocation. In carbocation, you had empty orbital. Here you have half filled p orbital. So sigma bond will have homolytic cleavage, and this hydrogen in the end will be having a free radical here because homolytic cleavage has happened, and here it will form this pi, this electron, and this electron will form a pi bond here. So the shifting of electrons we can say is going from sigma to half filled p orbital. This is the half filled p orbital in case of free radical. Ma'am, what about the application here? What about the application? Application is same. More the number of alpha hydrogens, more is the stability of the free radical, right? Next is very, very important. In case of alkenes, they can ask you where you are doing the movement. This is very important. See, in case of carbocation, nobody is going to ask you. In case of free radical, nobody is going to ask. Why? It is very simple. Sigma to half filled, sigma to empty, right? Here, it is moving from sigma to pi star, anti-bonding orbital, right? So, exactly what will happen, because this carbon is already complete. It already has double bond here, right? So, that is why it will have an anti-bonding orbital, that to pi anti-bonding orbital, where this electron is going to jump, then this pi bond is going to shift here, right? So one thing you should remember is the electron movement is from sigma to pi star, that is sigma to anti-bonding pi orbital. That is the first thing that you should remember, right? Now let us do some questions based on it, okay? Based on alkene, let us do some question, how they will ask you the question in the exam. how they ask questions in the exam. Let us do that. Okay. Sigma boy. क्या? Sigma boy, sigma boy, sigma boy. Yes. Sigma is a sigma boy. That is why a sigma boy is what? A sigma boy is very difficult to break. Okay. So whenever we are doing hyperconjugation, we have to break the sigma boy. Okay. So a lot of energy is required to break this bond. That is why it is called hyperconjugation. Right? Okay. Hyperconjugation. No bond resonance. Sigma is like I don't want to have any bond with anyone. Okay. So there is no bond resonance because sigma boy is having no bond with anyone out there. Right? This is a sigma man. Right? So now let us see this here. If you talk about these structures, it is having 12 hyperconjugating structure, 3, 3, 3, 3, 12 hydrogens. So maximum, this is 9, 3, 4, 5, 6, 7, 8, 9. This is 3 plus 3, that is 6. This is only, this is having no hyperconjugating structure, right? No alpha hydrogen is there. So according to that, you have the hyperconjugation and the stability. Important is this question. This question is highly important. So everybody, let us talk about this question here, right? It's the most important question, okay? Let us talk about this, right? नहीं यार, that तो I don't know. That तो I don't know, Malika. I think you guys always makes me feel that I am not Gen Z. I try to be Gen Z, but whenever there is some new thing, that new thing come up, now I didn't knew that there is something called Sigma Boy, and that is a song. Okay, so you guys are too much like advanced as compared to your this old teacher who is teaching you. You always teach me some new things about Gen Z, the new vocab of Gen Z. Acha, this is A, B, C. If you see this here, this is also having 6 alpha hydrogen. This is also having 6 alpha hydrogen. This is also having 6 alpha hydrogen. So basically, all of them have 6 alpha hydrogens only. Now the next question is, ma'am, if all of them have 6 alpha hydrogens, then ma'am, how will we differentiate that which is more stable, which is less stable? Right? Okay. Okay. Now let us see that. If you talk about this thing here, this is trans. Okay. If you talk about this thing here, CH3, hydrogen, hydrogen on same side. Here hydrogen, hydrogen on opposite side. This is trans and this is cis. Right? This is cis. Okay. So that is why, because trans is more stable as compared to cis. See, trans has less repulsion. Okay. You have CH3, CH3 on the opposite side. So it has less repulsion. That is why trans is going to be more stable as compared to cis. So that is why B is more stable as compared to C. Now you have to, this is neither cis, neither trans, beta. If you see geometrical isomer, geometrical isomer is that this is 1, this is 2, this is 3, this is 4. 1 should not be equal to 2, 3 should not be equal to 4. This is what we call geometrical isomer, cis and trans. Here 1 is equals to 2. Here you have hydrogen, here you have hydrogen. Here you have CH3, here you have CH3. So it is not neither cis, neither it is trans. So you have to tell me whether E is maximum stable or least stable. That is the question. Okay. Garbage song and no need to know. Chalo, good. All I know is chemistry, right, and some good songs. Ouch, 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 ouch. Bhagwan. Okay. Now, let us see which is more stable, right? The one that is not showing any geometrical isomer, is that stable or not? For that, you need to know this concept here. That is, you have CH3. If you draw this here, that is nothing but this is CH2 double bond C, CH3, CH3. CH2 double bond C, CH3, CH3. Okay? So I have drawn A here. What about trans here? This is CH3, CH3, C double bond CH3. Okay? So this is CH3, C double bond. Then again you will have CH. Okay. Now what you just need to expand one CH3 here. This is the CH3 that I have written. This is the CH3 that we have written. Now if you talk about the hyperconjugation structure here, what you will see, hyperconjugation structure means this is the alkene part, this is alpha carbon. So this alpha hydrogen will be basically, this alpha hydrogen is going to show the hyperconjugation. So this sigma will jump here and it will get converted to pi, right? This pi bond will jump here and it will get converted to the negative charge. So here you have the negative charge. This is CH3. This is the double bond. This is CH2. This is the structure that you have formed here, right? Here you do the same thing. This is the alpha hydrogen, alpha carbon. This is alpha hydrogen. This sigma will shift here as pi bond and this pi bond will shift here as negative charge. So this is the overall hyperconjugation structure that you will have here. Now what you will see, that this particular, this is negative, this is single bond, this is double bond, this is negative, and here you have CH3 directly attached. If CH3 is directly attached to a negative, negative does not want any electron donating group. Negative want minus, that means it wants electron withdrawing group. And here you are giving the electron, making it unstable. Here to this negative, you don't have any CH3. The CH3 is there, but it is not directly connected to the negative charge. So that is why this particular carbon ion is not going to get very unstable here. That is why A is more stable as compared to B. So the answer here is A, then you have B, then you have C. Got it? Yes, everybody, or not? Right? Okay. Chalo. Me, Malika, I had no intention for that. Okay. Let us see this carbon ion. Talking about carbon ion here. So this is CH3. See, why carbon ion never shows hyperconjugation? First question they can ask you. Because p orbitals are not empty. है ना? Where this bond is going to go? Nowhere, na? Because this is already fully filled. So that is why carbon ion never shows hyperconjugation, but in one case it shows. If you have some electron withdrawing group attached to the carbon ion, right? So basically what you have here is CCl3 and C negative. If to the alpha carbon instead of hydrogen you have Cl, this is minus, this is electron withdrawing, this is also electron withdrawing. That is why what will happen, what exactly is going to happen here, this orbital, we are not going to give the electrons to this carbon ion. We are going to take away electrons from this carbon ion. So we take away electron from the carbon ion, you form a pi bond here, and the electron will shift to this side. You will have Cl negative here. This is the hyperconjugation structure that you will form because you are taking away the electron from the carbon ion. So that is why it is minus H, right? So minus H also exists, but very rare. Okay. Next is electromeric. Now third topic also we have completed. Next is electromeric, right? Individually, how you will do the question based on stability, we will do once we have completed all the effects here. Next is electromeric effect, that is a temporary effect, right? So here what will happen, based on the external reagent, you will have plus C or minus C. Here also they have asked the question, right? So how they can ask you the question on the form of statements, that in electromeric effect what happens, in plus C minus I what happens. According to that they can ask you the statement based question. Okay, so here what you need to remember, that we know that this is the carbon, this is the oxygen, because this is more electronegative, so electrons will jump here. Here you have H positive, it will go to that direction which has more number of electrons, so it will jump to this side. Now electrons, the movement of electron and the attack of the reagent are on the same atom, that is why it is called plus C effect. In this way you can see electrons are going to jump here because this is more electronegative, and this is Cn negative, it is going to attack on the positive, which is it is going to attack on that atom which is less electronegative, that is carbon. So the position of the electron, that is the movement of the electron and the attack of the reagent are on the opposite species. That is why this is minus E effect. So what you can say, shifting of electron and the attacking of reagent on same atom, shifting of electron and attacking of reagent on different atoms, that is called minus E. Simple definition. Okay, got it? Next beta we have aromaticity. Okay, after that we will do questions based on stability of intermediates, combining all these effects here. Okay, okay, shall we start that or not? Okay, students, shall we start that? Yes, beta. I can't see your energies here. Anji, everybody. I can't see your energies. It is dropping, dropping, dropping. That too for organic chemistry, it is dropping, is it? That is a bad thing that it is dropping here. Only Malika is there, which is active. Rest of the students. Atik is active. Counting stars is active. Right? Yes, students, let's go, ma'am. Let's go. Where? Okay. So now, beta, let us do aromaticity. Aromaticity, basically, you should know that which is aromatic, which is anti-aromatic, which is non-aromatic in nature. So if you talk about this thing here, planar, complete conjugation and cyclic. These are the things that is called PCC. Okay, PCC, Priyanka Chopra. So you just have to remember that if PCC is applied, if PCC is not applied. So what you should remember, that always check for PCC, right? Whether PC is there or not. Now, if you see this here, if you have PCC followed, if PCC you are following, then you will say, then you have to check the electrons. If electrons are 4n plus 2 pi electrons, it is aromatic. If electrons are 4n pi electrons, then it is anti-aromatic. And if it is not following PCC, then it is non-aromatic in nature. And always aromatic is more than non-aromatic, then you have anti-aromatic. Aromatic, then non-aromatic, anti-aromatic is the least stable out of this. Right? Okay. Then complete conjugation, ma'am. What is PCC? For PCC, beta, just remember that if you have complete conjugation, right, that is called C, conjugation, complete conjugation. What is P? P means planarity. Planarity means it should be sp2 hybridized. So remember that if you have carbocation, which is under delocalized state, it is also sp2. If you have carbon ion, which is in delocalized state, it is also sp2. Okay? Carbon ion, if you talk about it is, if carbon ion, if you talk about in not delocalized, it is localized. So it has 3 sigma, 1 negative charge, that means total 4. That means sp3 hybridization. So carbon ion in localized form, it is sp3, that is not planar. But in complete conjugation, always carbon ion will be delocalized. That is why always negative charge will be sp2 hybridized. How it is sp2 hybridized here? If you see this, this is CH2. See, this carbon is having 3 sigma, but this negative charge is not fully on this carbon. That is why we can't include that in the hybridization. That is why it is always sp2 hybridized. Okay. Now this benzene, this is one of the example of aromatic compounds. It has PCC, planar, it is complete conjugation, it is also cyclic, right? 6 pi electrons means 1, 2, 3, 4, 5, 6. 6 pi electrons, that means 4n plus 2 pi electrons, that is, it is aromatic in nature, right? Similarly, if you talk about these kind of electrons here, PCC is followed here, PCC is followed here, right? Now it is having 1, 2, 2 pi electron, here it is 1, 2, 3, 4 pi electron. 4 pi means it is anti-aromatic, 2 pi means it is 4n plus 2 pi electrons. If you take n is equals to 0, so that will become aromatic in nature. right? These two are very important. Now I'm going to tell you a very important concept here, right? That is, we will calculate only those electrons in the pi electrons which are involved in delocalization. Okay. So here this nitrogen is involved in delocalization. This lone pair is involved. So it will be 1, 2, 3, 4, 5, 6. That is why it is aromatic. Right. But talking about this oxygen here, the problem is, ma'am, these two electrons are there in the pi electrons. But out of these two lone pair, only one of the lone pair will be involved in the delocalization. This will not be involved, right? This will be there in the hybridization. That is why 1 sigma, 2 sigma, 3 lone pair. 2 sigma bonds and 1 lone pair makes it sp2. That is why this oxygen is sp2 because of the lone pair and these 2 sigma bonds. Because of the other lone pair which is involved in delocalization, it is 1, 2, 3, 4, 5, 6 pi electrons, which is 4n plus 2 pi, which becomes aromatic in nature, right? One more example here. Let's talk about these two things here. Okay, let's talk about these two things, beta. You should know the concept very, very beautifully here. So this is boron. This is 1 and 2 pi. Okay, 2 pi bonds. One thing you should remember is, firstly, will cyclic conjugation happen here or not? This is cyclic in nature. If you see this boron here, 1, 2, 3. 3 sigma means it is sp2. Planar it is in nature. What about conjugation? 2 pi bonds, but here you don't have any positive or negative charge. Then how conjugation is happening? Because this boron has vacant, it is electron deficient in nature. That is why this conjugation will happen. That is why we can say complete conjugation it is. So it is PCC, planar, complete conjugation and cyclic, right? It is followed. After that, when we have to calculate the electrons, 1, 2, 3, 4. Because this boron has electron deficiency, but it does not have any electrons extra here. So it is 1, 2, 3, 4. That is why it is 4n pi electron, that it is anti-aromatic in nature. Similarly, we will look for this one. Very, very important. Very, very important. If you see this here, what you will see, can you see this particular thing here, students? So this is the molecule, right? Now here what you will see, this nitrogen, let me just show you that on a different page because this is very, very important. This is going to clear most of your concepts, right? This nitrogen, okay. Double bond, double bond. Beta, see. If you see this here, PCC, is it planar or not? This is sp2, sp2, sp2. What about this nitrogen? It is having 1 lone pair, 1, 2, 3 sigma bonds, right? And 1 lone pair. Should I involve this lone pair in the hybridization? The answer is no. Because this lone pair is involved in the delocalization. So this lone pair is not involved in the hybridization. That is why 1, 2, 3, 3 sigma means it is sp2, right? Now, this nitrogen here, it also has lone pairs. It also has lone pairs. It also has lone pairs, right? But these lone pairs are not involved in the resonance, right? Because lone pair with the double bond, it will not, it has lone pair, single bond, double bond. It is lone pair, double bond. So it is not involved in the resonance. So that is why this is not involved in the resonance. So this is included in hybridization. That is why it is 1, 2 sigma plus 1 lone pair, 3, that is sp2, right? So hybridization means it is planar. Complete conjugation, we can see complete conjugation, and it is also cyclic. PCC is followed. Now let us calculate the electron. 1, 2, 3, 4, 5, 6. Okay? So total it is 6 pi electrons. These are not involved in resonance. This is involved in resonance. Only these electrons are calculated in the pi electron calculation. So it is 6 pi electron. That means it is aromatic in nature. Is that clear? Is that clear to everybody? Huh. Yes, yes, I'll do that after anolines, right? Chalo. Now let us see anolines here, right? For anolines, what you have? Complete conjugation, very important thing. You should have complete conjugation, right? Monocyclic, it should be complete conjugation, monocyclic, right? Only one cyclic, and complete conjugation should be there. And the number here that will represent the aniline will tell you the number of carbon or the number of pi electrons here. That is a simple trick. For example, you have 1, 2, 3, 4 carbon. Okay, so 4 pi electrons you will have, right? Okay, so that is 4 pi electrons. Now, because it is monocyclic, it is complete conjugation, so it is aniline, right? Everything is planar here, PCC is followed, number of electrons are 4 pi electrons, so it is anti-aromatic in nature. Talking about benzene, which is 6-aniline, it has 6 pi electrons, so it is aromatic in nature, 4n plus 2 pi electrons, right? 8-aniline, very, very important, and this is what they ask you, as I have already written, it is very, very important. Now you have to remember that 8-aniline, 10-aniline and 12-aniline are non-planar in nature, right? So 8-aniline, why it is non-planar in nature? Because it has tub-like structure, okay? Tub-like structure it has. This is not the real structure of 8-aniline. This is the real structure of 8-aniline because it is non-planar, so it doesn't matter how many electrons it has, automatically it becomes non-aromatic in nature, right? 10-aniline is also non-planar, but it is non-planar because of the repulsions of these two hydrogens. So 10-aniline is also non-planar because of hydrogen repulsion. It becomes out of plane, so it is also non-planar. So that is why it is non-aromatic in nature. Talking about 12-aniline, it is again non-planar, okay, because of the repulsions here. Again, it is non-aromatic in nature. So what you have to remember, 8-aniline is non-planar because of tub-like structure. 10-aniline and 12-aniline are non-planar because of the hydrogen repulsions. That is why these three will become non-aromatic. In all the other anilines, there is no such thing as non-planar if you talk about our syllabus, right? So this is 14 aniline. This is no repulsion because the structure is large. So that is why no repulsion. 14 aniline means you have 14 pi electrons, that becomes 4n plus 2. If you put n is equals to 3, that will become 4n plus 2 pi electrons. So answer is, it is aromatic in nature. Then you have 16 aniline, again no repulsion, nothing. 16 pi electrons you have here. That means it will be 4n pi electrons if you put n is equals to 4. So it is again anti-aromatic in nature, right? Next is 18 aniline. Now here also what you can see, there is no hydrogen repulsion. The electrons are 4n plus 2 pi electrons only. So that is, if you put n is equals to, let's say 4, if you put n is equals to 4, 4 into 4, 16 plus 2, that is 18 pi electrons only. So it is aromatic in nature, right? So in the end, what you have to remember is this thing. That is, for anilines, what are non-planar aniline? 8, 10 and 12. 8 because of tub-like structure, 10 and 12 because of hydrogen repulsion. Because they are non-planar, that is why they are non-aromatic in nature. But if you talk about planar anilines, that is 4, 6, 14, 16, 18, all are planar. That is why you have to check the number of electrons. The one who has this much number of electron is anti-aromatic, this much number of electron is aromatic in nature. Is that clear to everybody or not? Right? Okay. Okay. Is that clear or not? Is that clear? Now I will do some questions of an aromatic, anti-aromatic here. Let us do questions of aromaticity here, right? Let us do some questions of aromaticity here. Let us see if you're able to solve that or not. After that, I'm going to give you break. And after the break, we are going to do rearrangement of carbocation, ring expansion, ring contraction, and stability of intermediates, and acidity and basicity. Okay? Understood? Chalo. Now let us do this. That is aromaticity. First is identify the molecules whether they are aromatic, anti-aromatic or non-aromatic, that you have to identify here. Okay, aromatic, non-aromatic or anti-aromatic. Okay, so if you see this here, let us see which of the following are non-aromatic, aromatic or anti-aromatic. If you see this here, this is 1, 2, these two electrons are involved in the resonance. So it is 6 pi electrons that it becomes aromatic in nature. Here it is, this is aromatic ring. This is, if you see this, double bond, single bond, double bond, double bond, double bond, single bond, double bond, single bond, double bond, single bond, double bond, single bond, lone pair, single bond, double bond. That means the resonance is complete conjugation, it is there. Right? Number of pi electrons that you can see is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? 10 pi electrons you can see. 10 pi electrons. That is 4n plus 2. If you put n is equals to 2, then it will be 4 into 2, 8 plus 2, that is 10. So this is also aromatic in nature, right? Here it is non-aromatic because there is no complete conjugation here, right? So it is non-aromatic. This is also non-aromatic because there is no complete conjugation here, right? So answer will be first two are aromatic, other two are non-aromatic in nature, which I can see in the comment section, right? Ma'am, benzene is always, this is benzene, but you have to see the full structure na here, full this thing, that double bond, single bond, double bond, single bond, lone pair, single bond, double bond, single bond, double bond, lone pair. Then we can say all of them are involved in the conjugation. Okay? So, next is how many of these compounds or ions are aromatic in nature. Let us see if you can answer this or not. How many of these are ions are aromatic or anti-aromatic? They are basically talking about aromatic, right? So this is 1, 2, 2 pi electron means it is, I'll just draw the electrons, okay? So this, you have to tell me how many of the following are aromatic or anti-aromatic. This is 2 pi electrons. This is 1, 2, 3, 4 pi electrons. This is 1, 2, 3, 4 pi, this is 1, 2, 3, 4, 5, 6, 6 pi electrons. 1, 2, 3, 4, 5, 6 pi electrons. 1, 2 pi electrons. Wait a minute. Okay. 2 pi electrons. Then here you have 4 pi electrons. And this is 1, 2, 3, 4, 5, 6 pi electrons. If you see this here, you have to firstly see whether they are following planar, complete conjugation and cyclic. Okay. So this is planar, PCC is followed. Here also PCC is followed, PCC is followed, PCC is followed, PCC, PCC, PCC. Okay, all of them PCC is followed. Okay. Now here 2 pi electrons means it is aromatic. 4 pi electrons means it is anti-aromatic because it is in the condition of 4n pi electrons. Right. Then here you have 6 pi electrons. It is also aromatic in nature. Right. Then 6 pi electrons aromatic, 2 pi electrons aromatic, 4 pi electrons anti-aromatic, 6 pi electrons aromatic. So here what will be the answer? How many are aromatic? 1, 2, 3, 4, 5. 5 of them are aromatic in nature. Very good. Karthi, Shini, very good, very good. Artik, KK, very good. 5 of them are aromatic in nature. 1, 2, 3, 4, 5. Rest 2 are anti-aromatic in nature. Right? Okay. Next is Acha. Next is basically the question of acidity or basicity. Acha, tell me if you want to do those questions now only. Next will be rearrangement. Na? So let us do some mixed questions here. After that, I'll start with the stability with some, after some break, we'll do that. Okay. So firstly, let us do some mixed questions here. Mm, Chalo, let us do some mixed questions here. Okay, let us do some mixed questions. 3, 4 mixed questions I'll do. Then we will start. Then after the break, we will start with the stability of intermediates, all those things, right? So among these compounds, which one has shortest CCl bond? Shortest CCl bond you have to tell. Okay, which has maybe double bond character that can have shortest CCl bond, right? Okay, shortest CCl bond. Anyone here? Shortest CCl bond. The one which has resonance will have shortest CCl bond because of the partial double bond character. Can you see? This is lone pair. This is also lone pair. Here also you have lone pair. Here also you have lone pair. But resonance is only possible in this case. Double bond, single bond, lone pair. Double bond, single bond, single bond. Double bond, single. There is no resonance here. No resonance here. Here also you don't have any resonance. Resonance is only present on the first part. So here the answer will be first. That is shortest CCl bond. So can you see indirectly they have asked you the question based on the resonance, but they have not asked you about resonance. They are saying they are asking you which of the following is showing resonance only, but they have asked this in a different manner. From the application of resonance, they have asked you this question. Okay. Next is the correct relation between bond lengths A and B. Bond length A and B. Again, this is from resonance. Bond length A and B. If you see this, this is CH3, C double bond O, O, CH3. These are the lone pairs, right? Now we know that this will be involved in the resonance, right? So this will have a partial double bond character. This will not have a partial double bond character. If this is A, this is B. Whenever you have a partial double bond character, the length will shorten, right? So tell me which one will have more length? Which one will have more length? Here partial double bond, here you don't have any partial double bond. So A will be less as compared to B. So answer will be B is the correct answer. Okay? Understood why this is the correct answer, everybody? Understood why this is A is less as compared to B? Because here you can see partial double bond character. Here you don't have any partial double bond character, right? So because here you don't have any partial double bond character, so that is why it is a single bond. It is a partial double bond. But double bond will shorten the length. So A is less as compared to B. So B is the correct answer. Next, let us see the question here. Give the order of stability for the following resonating structures. Order of stability for the following resonating structures you have to tell. So firstly, you need to see, I told you, then whenever you have to give the order of the stability, firstly check which of the following is neutral. So I can see that the second part is not neutral. This is also having negative charge, and negative charge. All of them are charged. So we have to check the pi bonds. 2 pi, 2 pi, 2 pi and 2 pi. So out of pi bonds also we can't answer. Third is the negative charge. Negative charge is more stable on oxygen or nitrogen. It says more stable along the period down the group. So oxygen, nitrogen, nitrogen, oxygen. So it is more stable on oxygen because along the period also more electronegativity, more is the stability of negative charge. So here you can see, if you see the carbon here, carbon will be present here, right? So negative charge is maximum stable on oxygen, which is present here. So A will be, first will be maximum stable, right? Next is, then it is more stable on nitrogen, that is on the third structure. Last is second because it is on the carbon, which is least stable, right? So answer will be B is the correct answer, 1, 3 and 2, right? Very good. B is the correct answer. Next, let us see. Okay, give the order of stability of following resonating structures. Order of stability, beta, you have to tell. Of the following resonating structures. What is the order of stability of the following resonating structures? Everybody, what is the order of stability of the following resonating structures? Let us see that here. See, give the order of stability of following resonating structures. If you talk about this thing here, first is the neutral. Which of the following? Can you see any neutral structure here? Can you see any neutral structure here? Yes. First one is the neutral structure. Can you see that? First one is the neutral structure. So first has the maximum stability. So C is automatically eliminated. Then then we have to see pi bonds. This is 1 pi bond, 0 pi bond, 0 pi bond, 1 pi bond. So either second or fifth. Out of second and fifth also, second and fifth you have to see. See second or fifth. Okay? So either second, so we can clearly see that D is the correct answer because the competition is between second and fifth. Others so don't have any pi bond, so they will be after second and fifth only. So the only option we have is D. But still, I will tell you that why second is more stable. Because here charge separation is less. That means more stability. That point also I told you, less charge separation means more stability. It is inversely proportional. More charge separation means less stability. So here it has less charge separation. That means it is going to give you more stability. So then you have second, then you have fifth. Out of fourth and third, ma'am, if I have to compare fourth and third, these two. Here it has positive, negative, negative. Now, beta, whenever two like charges are on the adjacent position, that makes it least stable. That is why third is the least stable here. So that is the reason D is the correct answer. Okay? Right? Beta, definitely they will ask you these kind of questions. That is why I am teaching you. Right? Next is the correct stability order of the following species. But it's not a big deal to do these questions. I think these are very, very simple questions that you can easily crack. The correct stability order of the following species. Nothing is neutral. Okay. Acha, following species they are saying. Okay. So you can compare, you can't compare actually between all of them. You can compare between these two because they two have only charges are different here, right? Okay. So many concepts are involved here, right? This will be basically based on the intermediate stability. So I will not teach you this here. This is an intermediate. Let me see any other question. Least stable. Then again, it is falling alkenes. Okay. So other questions are basically based on the carbocation stability and intermediate stability. Okay. That we will do. That we will definitely do. Wait a minute. Where is this? Huh. Other things are beta based on the carbocation stability. So just remember one thing. Questions we will do after the break. Okay? Do you guys want break or not? Everybody let me know. Do you guys want break or not? Let me know in the comment section. Right? Welcome beta. Welcome, welcome. Now, just remember one thing. In between the break, na, you can practice this for yourself. Whenever you have stability of intermediates, okay? Okay, just one concept now you have to remember. Stability of intermediates, when you talk about this, always remember one concept here, that is, anybody? Barhi. Okay, what is that Barhi? Anybody? Just remember this thing. Till now, what we have done, we just have to apply it in the questions. Now, theory part we have done. Okay, after the break, we will solve some questions based on Barhi. What is that? maximum, then it decreases. That means back bonding, you will prioritize it on the maximum. Then then you will look for aromaticity. Then you will look for resonance. Then hyperconjugation. Last one is inductive. Last one is inductive. Okay? So because of only this concept, I taught you so many things before, right? Because most of the questions based not means what they do is they ask you question based on acidity, basicity, and stability of intermediate. That you can do only with this concept, that is Barhi, that is your uh, priority of the different effects here, right? That is Barhi. Now, what we will do after the break, now we will take break. After the break, we will do questions based on stability of intermediate, acidity, basicity. Then last is a very small topic, that is the rearrangement of carbocation, ring expansion, ring contraction, that we are going to do. Right? Okay. Back, aromaticity, resonance, hyperconjugation, inductive. Yes, that is right. Okay. So now how long you want to take the break? How long you want to take the break? It's 2:20 almost. How long you want to take the break? Let me know in the comment section. By that time, I should tell you one more thing. That beta, our batch is going on. That is NEET crash batch. That is right now going on, right? And we have completed almost 5 to 6 chapters of chemistry there, right? Along with the previous year question, everything we are doing there. So basically, what we are doing is quick and smart revision, right? With the help of previous year question discussions and mock tests also we take every Sunday, right? That is there. Full analysis will be given to you. You have your doubt app, you have QR short notes, QR cards that are your short notes, right? You're also provided with the All India test series, right? So basically, All India test series, you will get 22 tests. This is there in the batch itself, right? Full test, part test, 11 test, 12 test, full 11, 12 tests are also there. Then you have Insta doubt solve. So basically, your instant doubt solve is there, right? If you have any doubt, you can get your doubt solved within 7 minutes, right? Then next one is your printed QR cards also we are providing you that in the batch itself. That is what is basically QR code, QR cards. These are the short notes, okay, that you can revise everything from these notes. Okay. Now, beta, quick and effective, complete coverage is there, portable and handy, expert curated, and interactive learning is there. You will see in these QR cards, right? Batch has started already from 17th of March, right? And the timings are from 10 a.m. till 10 p.m. In between, you have break from 1:30 to 6:30. You have break, right? Then other are everything is your fixed sessions for zoology, botany, chemistry, and physics. We daily take the lectures, right? Test timing is every Sunday, right? 2 p.m. to 5 p.m. Right? Now, if you talk about the batch here, so basically, students, what we have for you is NEET Crash Pro batch, where you get everything along with AITS, unlimited doubt app access, and QR cards also. But if you have already purchased the AITS and your doubt app is already there, someone is there to teach you, right? And you have AITS, because doubts are something that we usually have when we are doing the mock test and lot of previous year question you are discussing. So this doubt app is very, very important for you. But still, if you have someone, your Didi Bhaiya, to teach you, right? Then you can go for this crash combo batch where we provide you the QR cards, right? Not All India Test Series, not doubt app. Now, if you want to also have QR cards, right, I will not advise you, if you don't have QR cards, then you should go for it, right? Because at this time you need that, right? But if you don't have that, right, go for this one. But if you already have it, if you already have purchased this, right, then go for this one, that is NEET Crash, where live session, online test, mock test, online pedagogy, VBuddy, everything is provided to you, right? The Fees also I have mentioned you here. This is for 1999, 2999, and 6499. Right? Okay. Understood, everybody? Now, how much time break you need? Ma'am, 5 minutes, ma'am, 250. Oh, there is no, it's like uh, Zameen Asman ka difference. 5 minutes, ma'am, 30 minutes, ma'am. Chalo, I'll go for in between. That is, I'll see you all at, let's say, 2:23 it is. So I'll see you all at 2, maybe 30, 40, 45. Okay? 2:45. 2:45, I'll see you all. Okay? See you all at 2:45 p.m. Thank you, beta. Really superb session. I mostly loved the concept. Thank you so much, Bright. Thank you so much. Now I'll see you all after the break. And by that time, you can do the revision of what we have studied today, right? Because only what we have studied till now, you will be able to do the rest of the questions if you have enough knowledge and you memorize those concepts of inductive, aromaticity, resonance, everything. Okay? So, see you all after the break. Okay, so everybody, welcome back to the class. Yes, everyone. Uh, Deep is asking me, ma'am, why you're wearing so many bangles? Here, I'm wearing so many bangles because I just got married, and this is a tradition that I have to wear these bangles for 40 days, right? And after that, right, things will be normal, right? Okay. Yes, everyone. So let us see rest of the things here that is regarding stability of intermediates. Okay. So for stability of intermediate, let us do some questions here, right? Now, according to the stability of intermediate, let me see some questions here only, right? Yes. Okay. So some questions on stability of intermediates. Let us see that. Let us do that. Right, everybody ready for the questions on stability of intermediates? Why can't I see students? I don't know what is the problem. Whenever ma'am is, but if you're not going to, if students are not coming in the sessions, then I'll just end the class, right? Because I'm not gonna waste my energy like that. Okay. Let me just wait for 5 minutes. If the students are joining, then I'll do this. Otherwise, so I'll have to end the class. Right? Okay? Let me just wait. At least the strength should be about 20-25 students should be there. Okay? Only then I can teach something. Otherwise, what is the point? Right? I am back. What about the other students? What about the other students? Yes. Chalo, good. Students are joining. Very good. Very good. All of you come back to the class. Okay. Now we have the correct stability order for the following species is. Beta, the correct stability order you have to tell for the following species is correct stability order. If we talk about this is oxygen. So basically, if you talk about this thing here, you can see that in this particular area, this here also, you can see the back bonding, right? Okay. This is 3-degree carbocation. So how you will tell? As I told you, it is Barhi. Okay, it is Barhi, right? So if you talk about this thing, this is also showing back bonding. This is also showing back bonding, right? This is back bonding plus 3 degree. This is back bonding plus 2 degree. This is just 2 degree and this is 1 degree. So always for carbocation, according to the inductive effect, 3 degree is more stable. Then it is 2 degree. Then you have 1 degree. So answer is going to be, firstly here it will be 3 degree, then 2 degree, then 1 degree. So first with the back bonding is going to be more stable. So it out of these two, it is 3 degree and back bonding. So it is going to be the maximum stable. So first this is eliminated, this is eliminated. Then after that, you will have 2 degree plus back bonding. Okay, it will be 2 degree plus back bonding, that is third. Then you will have second, then you will have fourth. Okay, so answer will be D is the correct answer. Okay, D is the, acha, that is not clear. Just give me a second. Let me just decrease the brightness here. I think now it would be better. Now, next question is, which of the following is least stable? This is also based on the stability of intermediates, right? Which of the following is least stable? If you see this thing here, is that visible to you now? Is that visible to you now? Right? Now, this is the least stable they are asking you. So talking about the least stable here, what you will have? This is nitrogen having negative charge, carbon having negative charge, carbon having negative charge on the double bond, right? Least stable they are asking you. So first thing is you should know that if out of them anything is neutral, okay, that will be maximum stable, nothing is neutral, right? Here you can see negative charge on nitrogen, negative charge on carbon. Here also negative charge on carbon. This is going to be maximum stable. This is going to be maximum stable because you have negative charge on the electron negative element, right? So it is going to be maximum stable. Out of this and this you have to choose, right? Then what you can see here also it is, wait a minute, here it is negative double bond, then Cl, then OH. It is negative double bond, then after some break you have OH and Cl, right? So least stable, I think it should be electron withdrawing group you have here. If you see this here, it is donation, है it is also donation. So it donates the electrons, this will jump here, right? Okay, so which is not possible in this case, but in this case, if this jumps here, then this is going to jump here. It is again, wait a minute, lone pair, right? Lone pair, single bond, single bond. Here it is lone pair, single bond, double bond, and on that double bond you have the negative charge. So I think the answer should be, but a screen, is it too bright? Okay, is it too bright? I'll just write it here. Okay, I'll just draw it here. This is 1, 2. This is the negative charge. This is nitrogen, negative charge. This is OH and this is Cl, right? Because here in this compound, nitrogen has the negative charge. That is why it is going to be maximum stable. Next is you have this thing, double bond, double bond. Here you have a negative charge. You have OH here. This is Cl here and this is the nitrogen here. Here negative charge is over the double bond, right? In this case also, what you can see, this is Cl, this is OH, this is double bond, this is the negative charge, this is the nitrogen here. Again, what you will see, negative charge is on the double bond. Because here what you have, negative charge, double bond, then you have lone pair extra here. So lone pair, single bond, double bond. This is lone pair, single bond, single bond. So according to this, there is no resonance. Here you have the resonance. Okay, so that is why this will be the least stable. The one which does not have any resonance here. So answer is going to be, this is the least stable. So answer is B is the correct answer. Okay. Now next question here it is. Find the order of stability of the following alkenes. Right now they are asking you the order of stability of the following alkenes. So what they have given, beta, this is based again on hyperconjugation also you can say. Beta, are you able to see this? I think now this is visible to you, right? Now if you see this here, this is the double bond, right? Here you have one alpha, this is alpha, this is the double bond, this is alpha, this is alpha, this is alpha, this is the double bond, this is alpha and this is alpha, right? If you see the number of alpha carbons here, right? If you see the number of alpha, see, you have to apply this concept of Barhi, right? Back bonding is not present here. Aromaticity is not present here. Resonance is not present here. You have to see the hyperconjugation effect, right? So that is why I will apply hyperconjugation here. So when I am applying hyperconjugation, this is 1 hydrogen, 2 hydrogen. Here it will be 1 hydrogen. So this is 3 alpha hydrogen, right? Here it is 2 hydrogens, 3 hydrogens, 2, 3, 4, 5, 6, 7 alpha hydrogens. Here it is 2 hydrogens, 2 hydrogens. So here it is, yes, this is going to be 4 alpha hydrogens. Okay. So answer is second, then you have third, then you have first. So answer is A is the correct answer. More the number of alpha hydrogens, more is the stability of the alkenes, right? Next we have, which of the following order is correct for the stability of these carbocations? So beta, when we are talking about carbocations, okay, understand now what about the carbocation stability. You have to see for a carbocation, now this is based on, here you have this particular thing also. That is the bridge. This is the bridge head. This is the carbon, right? Basically, when you have a bridgehead atom here, then things will slightly change in this case. Okay. Now you have to tell the correct order for the stability of these carbocations. Right? Okay. Let us see this. Let us see this. If you see this carbocation, this is bounded to two other carbons, so it is 2 degree. This is bounded to 1 to 3 other carbons, so it is 3 degree. This is also bounded to 1 to 3 other carbons, so this is also 3 degree. So one thing is clear that third will be least. Okay, one thing is clear. But see, if you talk about second and third, third is going to be less as compared to second. But the question is between first. Okay, first is different, right? Can you tell me the reason behind that? Because this particular position is not very stable for the carbocation. So order is going to be, this is the least stable. Because on this position, the positive sp, because this will become sp2 hybridized, right? sp2 carbon is not stable on this position, right? That is why this will become the least stable. So answer will be second, then third, then you will have first. So answer is D is the correct answer. Okay, because this position is sp2, which is not stable. So carbocation is not stable at this position. Okay. Okay, positive charge on bridged carbon is unstable. Thus, the order of stability will become this. Right, next is which of the following is least stable? Again, you will have to see Barhi. Barhi. Again, beta, whenever they are asking you the stability of intermediates, always write Barhi there. Right? Okay. Now, let us see. Firstly, back bonding. Is there any back bonding in any of the cases? Back bonding, can you see back bonding in any of the cases? No, right? Can we see aromaticity here? Yes, this is aromatic in nature, 1, 2, 3, 4, 6 pi electron. This is aromatic in nature. This is also aromatic in nature. This is also aromatic in nature. But this is non-aromatic in nature. So according to the aromaticity, D will become the least stable. So we don't have to look for other concepts. If we are saying, okay, from aromaticity we can answer, then you don't have to go through resonance here, right? Next is which of the following chemical system is non-aromatic? Directly they are asking you which is non-aromatic. So as you can see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. See, non-aromatic means it should be non-planar. Maybe this PCC should not be followed here. Planar, all of them are. As you can see, this is non-aromatic because this is hydrogen, this is hydrogen. This point is sp3 hybridized. This carbon is sp3 hybridized. That is the reason here there is no complete conjugation. It is non-planar. So that is why this will become non-aromatic in nature. Okay, non-aromatic in nature. Okay, next question is, which compound of the following are non-aromatic? Non-aromatic you have to tell. See, 1, 2, this is basically, this is PCC is followed, so it is not going to be non-aromatic, right? It is 2 pi electrons, so it is aromatic in nature. This is 1, 2, 3, this is anti-aromatic in nature because 4 pi electrons it has. Here 1, 2, 3, 4, 5, 6, 7, 8, 8 pi electrons. Again, it is anti-aromatic in nature. They are asking you not aromatic. They are not asking you non-aromatic. They are asking you not aromatic. Not aromatic. Okay? So either non-aromatic or anti-aromatic you have to answer. This is non-aromatic. Reason being because it is no complete conjugation is there. Right? So answer will be second, third and fourth are not aromatic. Only this is aromatic. So answer is A is the correct answer. Okay, answer will be A is the correct answer. Right? Next is we have among these compounds, 1, 2, 3, 4, the compound which is not aromatic, again you have to tell which of the following compound is either anti-aromatic or non-aromatic. Okay? So you say double, single, double, single, double, single, double, single, double, single, double. So this is complete conjugation 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 pi electrons means 4n plus 2 pi electrons. So this is aromatic. This is 1, 2, 3, 4. Here lone pairs, it will show the conjugation here. So 1, 2, 3, 4, 5, 6. Again, it is aromatic in nature. Right? What about this one? Double, single, double, single, double, single, double, single. Again, alternate double bond, single bond. 1, 2, 3, 4, 5, 6, 7, 8. 8 pi electrons. That is anti-aromatic. 8 pi electrons. This was 10 pi electrons. This was 6 pi electrons. So this is anti-aromatic. Right? What about this one? Here it is lone pairs involved in the delocalization 1, 2, 3, 4, 5, 6 pi electrons. Again, it is aromatic in nature. So, which of the following is not aromatic? Only B, that is second, is non-aromatic, not aromatic. Basically, it is anti-aromatic in nature. Beta, there is difference between non-aromatic and not aromatic. Not aromatic means they are asking about which of the following does not belong to aromatic. Non-aromatic is a category, right? Among the given species, the resonance stabilized carbocations are. You have to tell resonance stabilized carbocation. Resonance stabilized carbocation if you need to tell. So if you see this, this will be resonance stabilized. Yes. If you see B also, double bond, single bond, resonance stabilized now. Double bond, single bond, single bond. This is not resonance stabilized. Double bond, single bond, single bond. And here you have double bond, single bond, single bond. This is also not resonance stabilized. This is double bond, single bond positive. This is resonance stabilized. So A and B are resonance stabilized. So answer will be A and B. Okay? A and B, that is C is the correct answer. Right? This is not, this is double bond, single bond, single bond. So this is eliminated. Double bond, single bond, single bond. This is also eliminated. Okay? So answer is only A and B are resonance stabilized. The compound that does not liberate CO2 on treatment with aqueous, this to beta you don't have to do because these are the questions from reactions. So this we will eliminate. Okay? This also is from reactions only. That also I'll eliminate here. Right? So mixed questions, guys, we have done. Let us go to acidity and basicity. Okay? Now let us move to acidity and basicity. How all these concepts are linked to each other, you will see this now, right? Acidity, see, you have Ha, right? Then it is going to give H positive plus A negative, right? For this concept, what you have to understand that a good acid is that one which loses H positive ion very easily. It will lose H positive ion easily if the carbon ion is very stable. So basically, whenever they ask you the stability, whenever they ask you the acidity, we have to look for the carbon ion stability. Okay. So carbon ion stability, I told you, you will do that on the basis of Barhi. Okay. You will do that on the basis of Barhi. And always remember, when you have a carbon ion, it needs negative. It needs electron withdrawing group to be more stable. Negative needs negative. That means a carbon ion needs electron withdrawing group to become more stable. Right. So now let us do some questions based on the acidity here. Right. Let us do some questions based on the acidity. Right. Okay. Why I can't see students here? I don't know what's the problem. Ma'am, teach, but ma'am, we don't want to study. I don't know what's the problem. I don't feel like teaching, guys. I really don't feel like. It's not at all good on your part to ask for a lecture and then don't come to that lecture. Right? It's not at all good on your part. Very disappointed by you guys. Very, very highly disappointed by you guys. So let's not do it, right? Okay, you do it yourself. I'll provide you with the PDF, right? Because you guys are not at all interested, right? You take things for granted, right? So I think it will be very stupid of me to teach here, right? Standing here, and I don't want to do that, right? So let's end this class now. Only other things I'll provide you with the notes, right? You can do that yourself because I feel you guys are very smart, right? So there is no need of me, right? Yes, this question I'll tell you that is there in on the board. Among the following compounds, the strongest acid is. Okay. So here it is alkene, benzene. This is CnH2n plus 2, that is alkene, right? Out of this, alcohol will be the strongest acid. So answer is going to be D is the correct answer. Okay. Yes. Beta, you want class, but why I can't see students in the class? Tell me one thing. Okay, tell me one thing. Why it is there that always I have to ask you, right? So I'll just, you tell me what to do. You guys tell me what to do. I'll do that only, right? I see that in next 10 minutes, if I see students are again not there in the class, so I'll end the class straight away. Rearrangement of carbocation, I've already taught this 2-3 months back. You can go and watch that video. That will be a lengthy video. Today's lecture was basically to combine those 1 month in just one lecture. I feel you guys are not at all interested in that. So if you're not interested, then I'm not interested. As simple as that. Right? Okay. So that is very, very disrespectful to see these things in the live class, right? So acidity I'm going to complete. After that, I'll see how many students. If not, then I'm going to end this session. I'm very, very serious about it. Okay. Now, if you see this here, this is OH, OH, OH. That means we are talking about phenols, right? This is NO2 electron withdrawing. This is NO2 electron withdrawing, electron withdrawing. Now, if you see any electron withdrawing group, right, you have to see what thing, you have to see the effects here. If you see Barhi, talking about the stability, this is negative, this is negative, this is negative. You have to talk about the stability of the electron, stability of the carbon ion. Now, what I will do, back bonding, can I see anywhere? No. Aromaticity? No. Can I see resonance? No. Resonance I can see, right? I can see resonance here, right? I can see inductive effect also here. So what I'll do here, on the meta position, always remember on meta, no mesomeric effect is applied. Okay, on meta position, no mesomeric effect is applied. So here it will be only, this is minus I effect. Here it will be minus I and minus M, right? Here it will be minus I and minus M, right? If you see this here, this is total electron withdrawing. So this is less dominating, right? Minus electron withdrawing is good for carbon. So if you are withdrawing it with less power, you are not stabilizing it to that much extent. That means first is going to be least stable here, right? So first is the least stable, right? Option we already got. Now out of third and second, because third is distance is more, right? That means in this case, what exactly is happening? This is minus I, this is also minus I. Here we are taking away the electron from the ortho position. This is from the para position. Okay? But in this case, one more effect we can see, that is the hydrogen bonding. Okay? Because of the hydrogen bonding, it makes very difficult for this hydrogen ion to get replaced, right? So that is why this second compound is not able to donate H positive and be a good acid. As compared to, so don't have to look into the effects here. What you will see, because of the hydrogen bonding, it is not able to give the H positive. That is why here it will be third, right? It will be third. So answer is going to be 3, 2 and 1. Wait a minute. Acha. Wait a minute. First will be the have I done it on the opposite side? Acha. Okay. I'm so sorry. Beta. I did it opposite. First is the least stable, I told you, no? First is least stable. So least stable is first here and here. So this is eliminated. Okay? Then because of hydrogen bonding, this second is not able to donate the electrons, donate the hydrogen atom. So this will be second and then third. Yes, then A is going to be the correct answer. I didn't see the increasing or decreasing order. So you have to see the increasing and decreasing order also. So first is the least stable because of it is only showing minus I effect, right? Then between second and third, second is less stable because of the hydrogen bonding. So answer is going to be A is the correct answer, right? Next is arrange the following in increasing order of pKa value. pKa value. Now, if you see Ka value is inversely proportional to pKa value, that means you need to look for the basicity here. Increasing order of pK. pKa is nothing but it is basicity. We are talking about basicity here. Okay? Ka means acidity, right? pK is inversely proportional. Basicity is also inversely proportional. So basically, we have to look for basicity value here, right? So if you see the value of basicity, because in case of amines, you have to look for basicity values only, right? So always remember, in case of basicity, directly proportional to electron donating group, inversely to electron withdrawing, it is directly proportional to availability of lone pairs. Okay, it is directly proportional to availability of lone pairs. Now here you have lone pair, here you have lone pair, here also you have lone pair. But in this case, lone pairs are maximum available. That means basicity is maximum in case of first, right? So in case of first, the basicity is maximum. Then you have second, but here you have two benzene. This is also benzene, na? So it is involved in the resonance. So lone pairs are less available. Then you will have second. In third, the lone pairs are involved in 3 benzene rings. So these are least available. So answer will be C is the correct answer. Got it? So all these questions based on acidity and basicity are frequently asked. Give the correct order of the increasing acidity of following compounds. Okay. So now you have to give the order of increasing acidity of the following compounds. This is phenol. This is simple COHC. In this case, what you will see, phenol has resonating structures, right? So definitely it is going to be maximum stable. Correct order of acidity. So phenol, that means first is going to have maximum stability of acidity. Then here you have, this is SP, right? This is also SP. Others are, this is OH and this is COH, right? Okay. So what you have to see, using acidity of the following compound. If I see this here, COOH, then it should be first, third, first, second, and then fourth. Okay. So the answer will be, if you see this, the answer will be here. Here it should be benzoic. Okay, it should be benzoic, right? Only then some of the option is possible. So maximum is benzoic. That means third, right? After third, you have first, that is phenol, right? Then after that, you have simple OH here, that is second. Then you have triple bond here. So answer is going to be B is the correct answer. But the condition is here you will have benzoic acid. Benzoic, then you will have phenol, then you will have OH, then you will have C triple bond C. Right? That will become the acidity order. Next is the increasing order of acidity of the hydrogen of the following compounds. Hydrogen of the following compounds, they are saying the increasing order of acidity of the hydrogen of the following compounds. Okay. So this is the CH3 here. Okay. This is H here. Okay, this is CH here. This is also CH3 here, right? This is also CH3 here. So if you have to talk about the acidity, increasing order of the acidity of the, I think it should be alpha hydrogen. Okay, it should be alpha hydrogen. Okay. Otherwise, so this question is incomplete. Okay, you need to have some alpha, beta, what hydrogen they are asking about. So this is alpha carbon. This is alpha carbon, right? This is alpha carbon. This is alpha carbon, right? So after losing this hydrogen, what is the compound that you are getting? Here you are getting CH2 negative. Here you are getting C negative. Here you are getting CH2 negative. You have to see which one is maximum stable. This is again CH2 negative. Okay. So if you see the stability here, which ion will be more stable? This is involved in conjugation. This is involved in 2 conjugation. This is involved in, here you have double bond. This will be shifted here. This will be shifted here. Then again it will have double negative single bond. Wait a minute. है ना? Then again it will have lone pair here. Lone pair, single bond, single bond. Lone pair, single bond. No extended conjugation it has. Right? Okay? So it has CH2 negative. Again, this is involved in the conjugation. Okay? All of them are getting involved in the conjugation with double bond 2. Right? But if you see this here, which will be most stable? The one which is more stable after losing the electron, right? So if you see this here, when you give electrons here, okay, when you give electrons here, it will give rise to this kind of geometry. Wait a minute, let us see. Double bond, this is CH2, this is single bond, this is O negative, this is N, this is CH3, this is CH3. Okay, so these are the lone pairs. Lone pair, single bond, double bond. Okay? This also can have one conjugation here. Here you are providing the electrons, so this is making it more stable. Right? You are donating the electrons here. Basically, from this side you have more donation. From this side also you are getting the electrons here. Right? Wait a minute. From this side also you are getting the electrons if you have negative here. Single charge. Wait a minute. Let me just see. I think the answer should be So let us see this. So basically, what has happened here? I'll tell you. Here you have on this side also it is donating. On this side also it is donating. Right? What I was checking is if there is any extended conjugation. Because here you don't have any extended conjugation. Here you see conjugation is one side only. It is two side. It is one side. It is also one side. So here you have 2 conjugations in the structure. Right? So B is going to have the maximum, like maximum acidity after losing the H positive. It is going to be maximum stable. Right? So that is why B is the maximum stability. After that, if you see this CH2 here, this is CH2 double bond, but here you have OMe, here you have NMe2, right? So now what has happened here? Here you have CH3 only, here you have CH3 means it is donating the electron with plus I, right? Once you have a negative charge, let's make a negative charge here. So what will happen here? This is CH2, this is negative. So what will happen here? I'll just draw the structure here. This is double bond because the electrons will jump here, double bond. This is CH2, this is O negative and this is CH3. Okay? So if you have simple CH3, it is going to donate the electron with plus I effect, right? With plus I effect means not that dominating. If instead of plus I you have OCH3, it is going to donate the electron, right, with the help of these lone pairs, right? Okay. Now, if you have N with 2 methyl group, that is where now what will happen? This is already negative. It is going to donate the electron with this nitrogen and with 2 methyl group, which is going to make it even more unstable. Because a negative charge does not want more electron donation. That is why here, then you will have A, then out of D and C, you know that this is more electronegative, right? Okay, so it would not want to donate the electron. This is less electronegative. This would want to donate the electron, but we don't want any donation, right? We want less donation. Just remember, we don't want any donation, right? In our resonating structure also, we don't want any donation. So this is more keen to provide the donation. Sorry, it is less keen to provide the donation. That is why you have C here. Then you have D because D wants to donate the electron. It has two methyl group. Then nitrogen is also less electronegative as compared to oxygen. So it would want to donate the electron with more ease. That is why this is very unstable. Okay, so answer is C. Got it? This is a very, very important question, right? Because 3-4 things they have asked you here regarding the resonating structure also formation you should know. Then you should also know that in the resonating structure, we don't want any electron donation, right? So that automatically becomes a very important question, right? Let me see how many more questions you have. The correct order of acidic strength of the following carboxylic acid. Okay? Carboxylic acid, the acidic strength they are asking. Again, this is O negative. This is negative. This is negative. Acidic strength means after losing H positive, what it will have? Negative. Now, the negative that you have, you need to have less donation. Just remember, for you need to have less electron donation. Only then that will be more stable and more acidic. So here you have, this is also sp carbon, this is also sp carbon. See, this is carbon, both will be sp, which are very high electron negative in nature. They don't want to donate the electron. More the S character, more is the electronegativity. They don't want to donate the electron. Here you have a double bond, right? Double bond. This is hydrogen and hydrogen, okay? Here you have OMe that is going to definitely donate the electron. This is CH3. This is CH2. So this is also going to donate the electron here, right? Okay. So that means if you talk about the stability here, right? If you talk about the stability, this is C double bond O, CH3, CH2. This is donating the electron on the para position with the resonating stuff, with the resonance. That is donating because of the inductive effect, because of this thing, right? Okay. So if you see this here, this is not going to donate the electron. That is why E is going to be maximum stable, right? Okay. After this is sp2, this is sp2. sp2 is still more less electronegative as compared to sp. See, if you talk about the stable, sp3 is least, then you have sp2, then you have sp, which has maximum electronegativity. Maximum electronegativity means least donation. sp2 is going to show more donation as compared to this, right? But here you don't have any as such resonance, right? That is why these two first, and after that you will have two, right? So this is automatically eliminated. Then you have OMe, but here I can see that it should be fourth and third. Fourth and then it should be third. This is what I feel, because but that is not there in the option only. So but what I feel is it should be fourth and then third. Reason being, because it is donating through mesomeric effect, which is more donation, right? But if you see, wait a minute, but distance is also there, na? Distance is also there. So what you can see here, yes, it will be 3 and 4th only, because here you have OMe, here you have inductive effect plus side donation, but here on the para position you have to donate it. So the distance is more. Here the distance is less, right? So it is maximum donation you have. That is why it is least stable, least acidic in nature. Okay, so answer will be A is the correct answer. Is that clear? Is that clear to everybody? Okay, this is pK value directly given to you, right? Okay. Next is pK value. So beta, you will obviously you will not learn the pK values, na? Right? So you have to get a like simple method here. What exactly, how to find the acidic nature. The increasing order of pK values of the following compounds. See, If you talk about pK values, that means again you have to see the acidity here. Okay? Inverse of acidity. Right? So firstly, I'll write the acidity value here. Right? Okay. So if you see this, this is phenol, phenol, phenol. Here you have electron withdrawing, electron. This is the same question. No? This is electron withdrawing, electron donating. So let us write the, firstly, let us write all the things that are happening here. First is if you talk about Barhi, then no back bonding, no aromaticity, there is resonance, there is no hyperconjugation, there is definitely inductive effect. Let us talk about resonance firstly. On para position, it is showing minus M and minus I effect. On meta, it is not showing minus M, it is only showing minus I, because on meta position, there is no mesomeric effect that will be applied. On here, why? Okay, now here you have, over here what you have, this is lone pair of electrons. So it is going to show plus M effect and minus I effect. Definitely plus M going to be more dominating here, right? Okay. Now let us see what you have to do here. This is phenol. So if you see this, this is electron withdrawing. You have to withdraw the electrons here, right? So this is negative, negative, negative. Now tell me for negative, you need electron withdrawing species. So this is showing a good amount of donation. So that is going to make it maximum stable. Okay. Okay. Then you have here also it is showing minus effect, but only least. That is only minus I, which is less as compared to minus M and minus I both together. Right. So that is why after this you will have C. Okay. Then it is not showing any effect. So it will be A. Then last will be the one which is showing plus M, least stable, because you are donating the electrons, you are making it even worse. Okay. So it is going to be D. So B, C, A, D is for acidity order. pKa will be opposite, that is BCAD. Okay, opposite order. So answer is D is the correct answer. Okay. Now next is for basicity. Okay. If you talk about the concept of basicity, in basicity what you have to do, just remember it is directly proportional to the electron donating group. Okay. More the electron donation, more the availability of lone pair, more is the basicity. So if you see this here, the strongest base they are asking you out of this, and basicity is asked from amines chapter. Okay, so here they are giving the donation, donating the electrons, right? Here it is taking away the electrons, right? It is taking away the electrons here. Here, if you see, it is also giving the electrons, but not through three-sided, right? Here it is 3 nitrogens you have. Okay, maximum availability you will have here. 1 nitrogen, second nitrogen, third nitrogen. And that too, if you talk about the lone pairs, this lone pair, this is lone pair, this will be lone pair, only donation will be present here. Right? So that means maximum number of lone pairs are provided on B. Okay, this is as it is, right? So answer will be B is the correct answer. Okay, maximum number of lone pairs, right? Then you have arranged the following in decreasing order of the basicity. Decreasing order of basicity you have to tell. This is the order of basicity only that you have to tell. So this is the simple order. That is, first is it is NH2, then you have OR, then you have OH, then you have RCO, then you have Ca. Okay, depending upon the electronegativity only we have this order, right? Okay, so this is the order of basicity. Next is give the correct order of decreasing order of basicity for the following compound. So this is a question where you need to definitely C6H6. So this is not benzene. C6H5 3, C2H5, okay, C6H5. Okay, so firstly you need to know the structures here. This is benzene and here you have NH2. This is 1, 2, this is CH3, CH2, right? Then you have NH, then again you have CH2, CH3, right? This one is C6H5 and you have 3 benzene here. 1, 2, and this is the third one. Okay. Then the next one is C6H11 and NH2. So that means C, you have 6 to 12. Okay. So this is, wait a minute. So this should be like this. No? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yes. Okay. It will be this kind of structure. Once you have drawn the structure, other things are easy only. Okay. Once you have drawn the structure, other things are easy only. So as you can see here, aniline that is donating. Here aniline, it is donating, not aniline, it is three benzene rings you have. It is donating to the maximum extent. Here, this chain is donating the electrons. So here, availability of lone pairs are maximum on this position. Maximum on second. Okay, so that will be B. Okay. Least stable will be this one, that is, wait a minute, this is A, this is B, this is C, this is D. Okay, so least stable will be C, that is fourth one will be least stable, right? This is eliminated, this is eliminated. Then you will have A, then you will have A, that is first. Okay, then you will have this, D will be the correct answer. Okay, so answer will be D is the correct answer here. Correct? Wait a minute, have I written it correctly? A, B, C, D. Decreasing order of basicity. Basicity decreasing order will not be. I'm so sorry, Beta. I'm so sorry. My mistake. I've just written it wrongly here. I'll just write it correctly. This is 1, 2, 3, and 4. Okay? So third is going to be the least stable. So automatically C will become the correct answer, right? Because third is by my mistake, I thought this is the fourth one, right? So third is the least stable because here lone pairs are not at all available for the donation, right? Then you will have the first one, right? Then here it is this one. On the second, you have the donation through the this CH3 CH2. Okay, so fourth is maximum, then you have first one because of the resonance here, then you have second, then you have the third one. Okay, next is, let us see, decreased order, the decreasing order of nucleophilicity. As a nucleophilicity you don't have to see. Okay, that is the reaction part only. That is in the reaction part. This you can see, this question you can tell. Consider the following benzyl alcohol and you have to tell the order, right? Consider the following benzyl alcohol, you have to tell the order of their Kb values. Kb values means the values of basicity, that means acidity inverse. See, if you see the order of acidity here, this is minus I effect and this is plus M effect, where minus I is more dominating, so I'll just write minus I. In this, plus M is more dominating, right? In this, plus M is more dominating. This minus M is more dominating, right? And here you have no effect. So if you talk about the acidity order here, more is the electron withdrawing, more stable it will be. So electron withdrawing is maximum in B. Okay, so that is 2 is going to have maximum acidity. Then you will have the fourth one, right? Then you will have the one which is having no effect, that is the first one. Then there will be the third one, that is having the donation, which is making it even least stable. So Kb value is opposite of that. So answer will be, you will have second, then fourth, then first, then third. Okay, second, then you have second, then fourth, then first, then third. So B is going to be the correct answer here. Okay? But the rest of the questions are same only, right? That I'll provide you the PDF, right? You can yourself go and check that out. Okay? Now I'll show you some questions of wait a minute, where it is. Let us see what is stability, what is the rearrangement of carbocation. Okay, let us go through that. What is the rearrangement of carbocation? Let us see that. So, rearrangement of carbocation is basically when you have to convert the carbocation into more stable carbocation, like by hydride, methyl, or phenyl shift. For example, you have this kind of compound. So, in this kind of compound, what you have, for example, you have this kind of compound. So, here what you will see, this is the compound that you have. This is 1 degree, primary. Okay. So, when you shift this hydride into this position, what you will see now see here the carbocation is on that carbon which is connected to only one carbon, so it is primary. If your carbocation is connected to two more carbons, so it will be 2 degree, it is secondary. Okay, then it will be 2 degree, that is secondary. So that is the reason here what we will see, because we can convert primary to secondary, we can make it more stable. That is why hydride shift will occur here and you will have a new carbocation. This is very, very important for your reaction part as well, because in so many reactions you will see wherever there is formation of carbocation, the chances are of rearrangement of carbocation, right? If you see the phenyl shift, let's say you have pH here. Now this is carbon is connected to only one carbon, so that is primary. If I shift this pH to this position, now I will have a 3 degree carbocation which is connected to 3 carbons, right? That means again I can rearrange it. Now if you talk about, ma'am, if I have to choose between which shift I should do. For example, here you have methyl also, phenyl also. So which shift I should do? So always remember that is happy me. That is hydrogen, phenyl and methyl. We always want us to be happy. So that is why rearrangement of carbocations also make you happy by giving you more stability, right? So H for hydrogen, PH phenyl, and then last one is the methyl. So if you have to choose between this phenyl and methyl, you will choose the shift of phenyl. So what we will do, we will shift the phenyl. Wait a minute, we will shift the phenyl here, right? So here it will be yes. You will be left with on this carbon, you will be left with one CH3 and one PH, and here you will have phenyl shift. Now this carbon is connected to 3 more carbon, that is why it is 3 degree, which is automatically more stable. Okay, got it? Now extended rearrangement is, for example, you have this primary. Okay, you have to, when you are doing one step rearrangement, you are shifting this hydride, right? Because hydride shift is more as compared to methyl shift, right? So when you are shifting this hydride here, you are getting 2 degree carbocation. That means more stability, right? If now you get 3 degree, that is now what we are doing, we are shifting it even more, right? Now you have this kind of shift. Now what you are doing here, wait a minute. This is the shift. This is the shift that you did before. This hydrogen was shifted. Now this hydrogen I am shifting. Now I'll get 1, 2, 3. This carbon is connected to first carbon, second carbon, and third carbon. So basically, this is my 3 degree carbocation. So if your carbocation, right, you have to convert it into 2 rearrangements, then in every rearrangement, you should get a stable carbocation. Only then extended rearrangement is possible. Okay, the concept of rearrangement is clear to you or not, everyone? The concept of rearrangement is clear or not? Hanji, tell me. The concept of rearrangement is clear or not? Now, I will see the next one. The concept of rearrangement, is that clear or not? Last one is ring expansion and ring contraction. So see, for ring expansion, what you have to remember, if you have a positive charge, okay? If you have a positive charge, this is the thing that you will have. Always in case of ring expansion, positive charge is out of the ring, not in the ring, okay? So here positive charge is out of the ring. Here also, when you have a ring structure, then you, instead of rearrangement, we call it ring expansion and ring contraction. Okay, so you have a ring here. This is CH2 positive. Now, beta, what you will do? A simple thing you should remember. join first carbon to the third carbon, put a positive charge on second carbon. Join first carbon. This is, let's say this is, see, one more thing, important thing that you should remember, that this ring will not be converted to 4. Okay? Because this is already a stable ring. Okay, this is already a stable ring. So this conversion will not be possible. Right? Let us talk about this conversion. Okay, let us talk about this conversion here. Talking about this conversion, beta, talking about this conversion here. This is 1, this is 2, this is 3. Okay? What I told you, join 1 and 2, 1 and 3, put a positive charge on 2. Okay, this is the same thing that we did. Positive charge on 2, join 1 and 3. This is nothing but 1, 2, 3, 4, 5 membered ring with a positive charge. So that is the ring expansion. Okay. Similarly, you can do for 5 membered, because see, 5 membered is more stable. See, if you see, 3 membered is more stable as compared to 4 membered. So you don't need to convert it into this, because you can see here, that this formation is not possible only. You can see there will be dancing resonance that is making this 3 membered ring already more stable. So you don't need to, make it, you don't need to convert it into 4 membered ring. But 6 membered ring is more stable as compared to 5 membered ring. That is why here expansion is possible. Okay? And here also 5 membered ring is more stable as compared to 4 membered ring. That is why here also expansion is possible. So expansion is only possible if you are converting into a stable ring. Here also what will happen, this is 1, 2, 3. You will join 1 and 3. You will put a positive charge on 2. Okay? And this is the 6 membered ring that you will get. Now 7 membered ring is less stable as compared to 6 membered ring. That is why this expansion will not occur. 6 membered ring will not be converted to 7 membered ring. That is not possible. The conversion is not possible. Right? Okay. Now you have ring contraction. Talking about ring contraction, same concept you will apply here. Put 1, 2, 3. Okay? 1, 2, 3 starting from here. One thing is that the carbocation will be on the ring. Okay? So this is present on the ring. So put 1, 2, 3, join 1 and 3. You have to join 1 and 3. Then put positive charge on 2. Same thing I did here. I joined 1 and 3. I put positive charge on 2. And this is what I will get here. Join 1 and 3. Put positive charge on 2. This is the structure that you will get here. You are converting 7 membered ring to 6 membered, because 6 membered is more stable as compared to 7 membered ring. Okay, that is why you converted. That is why contraction happened here. Right? Okay or not? Everybody tell me, is that clear to all of you or not? I'll see some questions based on, I think it should be there. Okay, it is not questions, it is simple, just I have already taught you. Okay. Because I'll just take this question here. How they ask you, okay, just to tell you basically how they ask you. See, they will not ask you the ring expansion, ring contraction directly, okay? They will not ask you that. But they will give you some reaction. Reaction we are going to do in next lecture, right? So here what you will do, we know that concentrated H2SO4, you have to know the mechanisms here. Mechanisms plus rearrangement will give you the answer here. Okay? So mechanisms we will do in the next lecture. So here H2SO4 means you have to take out the OH here, and this will give rise to this kind of carbocation C, CH3, this is CH3, this is CH, this is positive, this is CH3. Now, you should know that in concentrated H2SO4, the mechanism is the formation of carbocation. You formed a carbocation. Now you see this is a 2-degree carbocation. But if I do the methyl shift here, I'll get C, CH3, this is CH. Methyl is shifted to this carbocation. And here you have the formation of new carbocation. which is nothing but 3 degree carbocation. Now you will have the new carbocation, right? This is called the rearrangement. Okay, this is called the rearrangement of the carbocation. Got it? Yes, everybody? So this is how you will get the questions in the exam. Similarly, from ring expansion and ring contraction, this I have already told you. For example, you have something like this. Okay, this is the carbo, this is the question that you will get. They will ask you on adding water what you will get. Now we know that on adding water here, what we have to do, we have to add H positive and OH negative here. But whenever we add H positive and OH negative in acid catalyzed hydration, there is formation of carbocation. This is how reactions and GOC are linked to each other. Okay, so you need to add it here, right? That is how you should also know the stability of carbocation. That is why I taught you the stability of carbocation, right? So now you have to add water according to the carbocation. So which carbocation will be formed here, right? So let's say here H positive got added, you have CH3, and this carbocation, you had the formation of this carbocation, right? So now this is CH positive, CH3, this is the carbocation, right? Now, can I see the positive charges outside the ring? Okay. The positive charges I'll show you with this method, right? Okay. Chalo, I'll write it here only. I'll write it here only. Okay. I'll write it here only what you have to do. So basically, this is the thing that you have here. This is CH. This is CH3. Okay. Now, what you will see here, very simple. Put 1 here, 2 here, and 3 here. Okay? You don't have to go through this thing. Just look at this thing. Now you have to attach 1 and 3. Okay? So what I'll do, I'll just copy paste this thing here. This is CH, this is CH3, this is positive, this is 1, 2, 3. So I'll just attach 1 and 3. So when I'll attach 1 and 3, it will be something like this. I have to break the bond of 1 and 2, right? Then I have to put positive here. Okay? Wait. Sorry, I have to break the bond of 2 and 3, and I have to put a positive charge on the second position. Okay? This is the compound that I will get. Okay? I attached 1 and 3, break the bond of 2 and 3, attach 1 and 3, and put positive on 2. This is what I did. Right? This is what I did. Right? Now, this is the carbocation. If I have to write it in a different manner, this is 1, 2, 3, 4, 1, 2, 3, 4, 5. So it is a 5-membered ring, right? Which has carbocation something here, and this is CH3 what you will have. Okay? So this is the new carbocation that I got. Right? This is the new carbocation that I got. Understood now? Now, what you have to understand here, right? If you see this carbocation, can you tell me this carbocation is 2 degree carbocation? Okay? This carbocation is 2 degree carbocation. If I can somehow convert it into 3 degree carbocation, I'll be more happy. So we know that here you have one hydrogen also. Okay? So now what will happen? This hydride shift will also take place, and this rearrangement of carbocation will occur, and this CH3 will be as it is. Instead, this hydride will shift to this position, and you will have a positive charge here. After this, OH negative will get added, and hence you will have this kind of compound in the end, CH3OH. Okay? So see what you started from and what you got in the end. Okay? Is that clear to everybody or not? Is that clear what we did here? Is that clear? So firstly, I did ring expansion. After ring expansion also, I was getting 2 degree. Then I converted it into 3 degree carbocation. I did rearrangement also. Then I got the final product. So that is how expansion, contraction, and rearrangement of carbocation will be useful to you when you are answering the questions of reactions which involve the formation of intermediate carbocation, right? Okay. Similarly, if you talk about ring contraction also, you will see the same thing. So this is four membered, right? We know that three membered ring is more stable. Can you tell me why? Because of dancing resonance, it is more stable, right? So here, what will happen? This is basically if you add H positive here, double bond will break. This will be H positive. This is CH2. H will be present here. This will be the positive. Okay. So when you have positive charge on the ring, this is positive charge on this carbon, right? Always there will be ring contraction. Contraction means this is 1, this is 2, this is 3. Okay. So what I told you, beta, everybody, what I told you that you have to join 1 and 3. So you will join 1 and 3, right? Put positive charge on 2. Okay, break the bond of 2 and 3. This bond you will break. So this is what you will get. 1, this cyclopropane, right? This is CH3 here, right? And here you will have the positive charge, right? Then you will add OH negative and hence the answer will be there. Okay? Okay. Better tell me in the comment section if that is clear to all of you or not. If that is clear, then let me know in the comment section if ring expansion and contraction is clear to all of you. Chalo. Now, beta, the lecture I'll end, but in the end, I'll say one thing that I'm very, very, very disappointed by all of you, right? So I didn't expected this kind of situation in the class for today, right? Because a lot of questions, especially for you, I picked out, right? But still, with courage, I completed the lecture. But trust me on that, I was not at all very happy with the lecture, right? You can see that on my face only. You can see that with the energy also. Next time, if you say that, ma'am, please take this session, be there, right? Then else don't say, right? Don't commit things that you are not able to do, right? So all those students who are watching this lecture, maybe in the recorded version, this and that, you should have told me that you are not interested in this lecture. I would have completed already my concept, so I have already completed, right? So I took extra lecture just for you, right? Otherwise, I would be free today, right? But I took extra efforts just for you guys, right? And what I see, very less live watching, very less, right? So that totally shows that you commit things, you get very excited that, ma'am, this we will do, and then you are not there. So this shows your level of commitment, right? My level of commitment, so you can see with this much students also, I was there till the end, right? I taught you everything till the end. But again, very, very disappointed by you guys, right? Can't do anything about it. What I can say is don't commit when you can't be there in the lecture, right? Then I'll do what I want to do. I took this specially for you, right? So now for all the students who are looking for the crash course, so guys, we have NEET Crash Pro that is already there. So basically our lectures are going on from, as you can see, if you see the session timings from 10 a.m. till 10 p.m. the sessions are going on, 10 to 11:30, then 12 to 1:30, then 6:30 to 8, then 8:30 to 10. In between, you will get the break also for your self revision, for your self note revision also you will get, right? In this, basically, what we are providing you for NEET Crash Pro, we are providing you with live sessions, online test and pedagogy, VBuddy. Then we are also providing you QR codes at home AITS All India Test Series. 22 tests you will get along with the mock test. We are also providing you the doubt app here, which you can get the instant solve of your question within 7 minutes, right? So all this is for 6499. For example, you have some bhaiya didi already there to tell your doubts, then that is fine. And you also have AITS All India Test Series. Then you should go for NEET Crash Combo Batch, where we are providing you live session, mock test, everything except for AITS and doubt app. If you have already purchased the QR cards, right, that are the short notes, then you should go for NEET crash batch, where test series, not test series, mock test every Sunday we are taking, right? And full analysis is given to you. Classes are going on the live classes, right? And also we are providing you DPPs, previous year question discussions, everything there in the NEET crash batch. That is for 1999. Okay? Yes. Chalo. So that is all for today. Then I'll see you all maybe on Friday or Saturday class. I'll let you know, right, which class I'm going to take, which I think most probably I'm going to take organic chemistry name reactions, right? Okay. So those students who are watching it for recorded, you have done a very good thing, because before Friday, if you have watched it recorded, then you have done a good thing, because name reactions are slightly connected to the GOC, right? Okay. So I'll see if either I'll pick isomerism or I'll pick GOC, or maybe I'll pick block chemistry. So I'll ask you in the poll of Telegram which thing you want me to do. According to that, I'll pick the topic. Okay. Okay then. Bye bye. Take care. See you all in the next class. Bye bye.